वेलकम डॉक्टर बापू.
सर नमस्ते. सर नमस्ते. गुड मॉर्निंग.
उशीर झाला आहे पण हार्टली वेलकम टू यू.
सर इट्स ओके.
Can we start program?
Yes sir. Yes sir.
दिवसाची सुरुवात होते सूर्याच्या केशरी किरणाने. दिवसाची सुरुवात होते सूर्याच्या केशरी किरणाने आणि कार्यक्रमाची सुरुवात होते प्रतिमा पूजनाने. अंधकाराकडून प्रकाशाकडे घेऊन जाणाऱ्या तेजाच्या पूजनाला भारतीय संस्कृतीमध्ये अनन्यसाधारण महत्व आहे. अज्ञानाच्या अंधकाराकडून ज्ञानाच्या प्रकाशाकडे घेऊन जाण्याची प्रार्थना आपण सरस्वती मातेला करूया. मी मान्यवरांना विनंती करतो की आपण या ठिकाणी प्रतिमा पूजनाने कार्यक्रमाची सुरुवात करावी.
म्हटलं की सगळ्यांना आठवते ती विठ्ठल वाघ सरांनी लिहिलेली रयत गीत. आपण कार्यक्रमाची सुरुवात रयत गीताने करणार आहोत.
रयते मधुनी नव्या युगाचा माणूस आता घडतो आहे. वटवृक्षाच्या विशालतेचा मोहन भाला पडतो आहे. रयते मधुनी नव्या युगाचा माणूस आता घडतो आहे. वटवृक्षाच्या विशालतेचा मोहन भाला पडतो आहे. रयते मधुनी नव्या युगाचा. कर्मवीरांचे ज्ञानपीठ हे शक्तिपीठ ही ठरते आहे. शाहू फुल्यांचे समानतेचे तत्वमानसी मूर्ते आहे. धर्म जातीच्या पाद गांधींचे मूल्य मानवी जपतो आहे. रयते मधुनी नव्या युगाचा माणूस आता घडतो आहे. वटवृक्षाच्या विशालतेचा मोहन भाला पडतो आहे. रयते मधुनी नव्या युगाचा. ही लेणी मोडून लक्ष्मी वहिनी झाली आई. कमवा आणि शिका मंत्र हा तरुणाईला प्रेरक होई. स्वावलंबी वृत्ती ठेवून ज्ञान साधना करतो आहे. रयते मधुनी नव्या युगाचा माणूस आता घडतो आहे. वटवृक्षाच्या विशालतेचा मोहन भाला पडतो आहे. रयते मधुनी नव्या युगाचा. दीनदलितांसाठी अण्णा तुमची झिजली चंदन काया, अनाथ जीवा सदा लाभली मातृहृदयी तुमची माया. शून्यामधल्या नवसृष्टीचा निर्मिक तोही ठरतो आहे. रयते मधुनी नव्या युगाचा माणूस आता घडतो आहे. वटवृक्षाच्या विशालतेचा मोहन भाला पडतो आहे. रयते मधुनी नव्या युगाचा. जीवनातला तिमिर जावा, प्रबोधनाची पहाट व्हावी. इथे लाभले पंखले उनी, उंच भरारी नभात घ्यावी. प्रतिभाशाली बहुजनांचा वेलू गगनी चढतो आहे. रयते मधुनी नव्या युगाचा माणूस आता घडतो आहे. वटवृक्षाच्या विशालतेचा मोहन भाला पडतो आहे. रयते मधुनी नव्या युगाचा.
कार्यक्रम असो त्यासाठी कार्यक्रमाची यशस्वी धोरण सांभाळण्यासाठी अध्यक्षांची गरज असते. म्हणून आजच्या आपल्या कार्यक्रमाचे अध्यक्षस्थान आपल्या सर्वांचे मार्गदर्शक तसेच आपल्या कॉलेजचे प्राचार्य माननीय डॉक्टर के.जे. कानडे सर यांनी स्वीकारावं अशी मी त्यांना विनंती करतो.
कार्यक्रमाला येऊन केले आपल्याला आपल्या कार्यक्रमाचे अध्यक्ष माननीय प्राचार्य डॉक्टर कानडे सर लाभले आहेत. त्यांचा सत्कार केमिस्ट्री डिपार्टमेंटचे हेड माननीय डॉक्टर काळे सर करतील अशी मी त्यांना विनंती करते.
आपल्या केमिस्ट्री डिपार्टमेंटचे हेड डॉक्टर काळे सरांचा सन्मान
यानंतर मी माननीय डॉक्टर काळे सर
वेलकम टू बापू सिंगे ऑनलाईन
माननीय काळे सर आपल्याला ऑनलाईन झूम मीटिंग द्वारे जे मार्गदर्शन करणार आहेत त्या मार्गदर्शक सरांचा स्वागत करते.
सिंगटे सर आपलं महाविद्यालयाच्या वतीनं आम्ही हार्दिक स्वागत करतो.
सर नमस्ते सर.
सर्वांना विनंती आहे की त्यांनी गाडी सरांचा सत्कार करावा. करावा. भाग सरांचा सत्कार शिंदे सरांनी करावा अशी विनंती.
आपल्या केमिस्ट्री डिपार्टमेंटचे हेड काळे सरांचा सन्मान डॉक्टर शिंदे सर करतील अशी मी त्यांना विनंती करतो. या ठिकाणी सत्कार समारंभ आपल्याला घ्यायचा आहे. काळे सरांचा सन्मान विद्यार्थी प्रतिनिधी प्रतिनिधी पाटील करेल अशी मी त्यांना विनंती करतो. विश्वास सरांचा सन्मान विश्वास करेल. शिंदे सरांचा सन्मान डॉक्टर सर ऋषिकेश तोरमलकर, वैभव सरांचा सन्मान सिद्धेश लांडेकर, सन्मान रसिका जगताप करेल. इंगे सरांचा सन्मान विद्यार्थी प्रतिनिधी नवला करेल. त्यानंतर इंदोर मॅडमचा सन्मान जनरल खंडकर करेल. यानंतर नायकोड मॅडमचा सन्मान काजल कोपरकर करेल. यानंतर गटे मॅडमचा सन्मान माया काळे करेल. यानंतर मेघा बागल मॅडमचा सन्मान ऋषिकेश शेटे करेल. यानंतर साक्षी बागल मॅडमचा सन्मान सोनाली डोबळे करेल.
एमएससी पार्टनरचे विद्यार्थी पुढे शिंदे बाबांचा सत्कार विद्यार्थी प्रतिनिधी आकाश पाटील. अरुण बाबांचा सत्कार विद्यार्थी प्रतिनिधी स्नेहल मनकर. विशाल कनाळेकरांचा सत्कार तुळशीदास पाटील करेल. शिंदे बाबांचा सत्कार विद्यार्थी प्रतिनिधी यानंतर एमएससी पार्टनरचे विद्यार्थी प्रतिनिधी अभिषेक दवंगे याचा सत्कार एमएससी पार्टनरचे विद्यार्थी पुन्हा पुढे करेल. यानंतर एमएससी पार्टनर विद्यार्थी प्रतिनिधी स्नेहल मनकर करेल.
बाकी राज्यातील सर्व एकदम
ज्ञानाचे कधी थांबले तणावारे, ज्ञानाचे कधी थांबले तणावारे, ज्ञानाने आहे विश्व व्यापले सारे. आधुनिक शब्दांचे शब्दांची प्राण आणि घडले विश्वव्यापी संवाद. मी विनंती करतो आपल्या सर्वांचे मार्गदर्शक आणि आपल्या केमिस्ट्री डिपार्टमेंटचे एचओडी डॉक्टर काळे सरांना आपण या ठिकाणी आपलं मनोगत व्यक्त करायचे.
झाली का फुलं घेऊन? फुली दो 2 मिनिटात फुले द्या. 50-25 मुलांना फुले द्यायला किती वेळ लागतो? सुट्टी देऊन टाका. चला बसा तुमच्या जागेवर. हे पहा. गुड मॉर्निंग वन अँड ऑल. I warmly welcome you all for this combined ceremony organized by Department of Chemistry, in which the first ceremony is a welcome function of the MSc part first chemistry students by the MSc part second chemistry students. And in addition to that, today we have also organized a very renowned lecture of Dr. Bapu Sahib Shinte from online lecture for you on the click chemistry. Respected dignitaries on dais, Honorable Principal of the College, Dr. K.G. Kannada, the President of this function, Vice Principal of the Science stream, Dr. Bolbert, Vice Principal of Arts and Commerce, Dr. Gardi sir, IQC coordinator of this college is Dr. G. Shivag, my senior colleagues, Dr. Misa, Daude sir, Dr. Shinde sir, Dr. Walvi, and all other my colleagues and teaching and non-teaching staff, and all dear students and online. Joined a resource person and our good friend, Dr. Bapu Shinte. On behalf of Anna Sahib College and Department of Chemistry, I warmly welcome Bapu Sahib Shinte sir. I'll begin with a few words about my department, Shinte sir. My department, particularly chemistry department, starts in 1985 as a BSc class. In 2010-12, we have started MSc first. MSc 1 division of organic chemistry under the guidance of Honorable Principal. Was he a professor at that time and head of the department? Started the MSc 1 division organic chemistry. 2017 we started second organic divisions, and 2019 we started one more analytical divisions. So total in all 72 is our intake of chemistry part 1. Organic and analyticals. We have also taken sufficient effort to start the research center of the chemistry, and we are very fortunate to say that the core faculty in my department is a research guide of Savitribai Phule Pune University, Pune. More than 13 students are registered for PhD. Shinte sir. This is a very good college in North Pune district. The world college is a reputed college. Students are also admitted to these PG courses from the various colleges of whole Maharashtra. From Satara, Sangli, from some students from Vidarbha, some from Marathwada and other region, Dhule, etc. I joined for MSc course. We have a routine practice of the teaching and conduction of the practical, but in addition to that, we take them to follow to do the research project. Few students of our research project, with their faculty, they will publish the research paper in the reputed journals. This is the contribution of the students. These departments are having good results. Department is running well under the control of Principal Dr. K.G. Kannada sir. This department is having good results, and we are also having good placements. We take the placement drive for the students. We take their revisions of different examinations so that get improving the results. Overall development of the students is our final aim. And therefore, we are running very well departments With these few words of the department, I would like to introduce in brief a very soon whose lecture we are eager to listen. Dr. Bapusaheb Shinte sir. Bapurao Shinte sir is a associate professor at BAMU, that is Dr. Babasaheb Ambedkar Marathwada University, Aurangabad. Sir is very renowned person in the chemistry. Presently, a very few rising sun in the chemistry are those who are very good at extended research. One of them, Dr. Bapusaheb Shinte is here. He is always accept our invitations and he is always with us. He is having a special love and affection about Registration Samstha, and even though our Anna Sahib Auto College Manchar, every year he is with us, offline as well as online mode, and for convey his knowledge to you all. Dr. Bapurao Shinte he did a PhD in the area of the organic chemistry. Presently, he is associate professor at Aurangabad. He has got various awards, that is ISCB Best Teacher Awards, Benjamin Ambassador Awards as a good publisher, Research Professor Awards from Babasaheb Ambedkar University, Aurangabad, Best Teacher Awards, also Indo-US Research Fellowship. Then Shikshak Pratibha Puraskar is also obtained from Babasaheb Ambedkar University. His current area of research is synthesis of bioactive compounds and new synthesis and new methodologies in organic synthesis. He has delivered near about 60 lectures in various national and international conferences. Also worked as a research person for 11 more repression as well as orientation courses, which was to be conducted for teachers. Even 60 more guest lectures, chaired more than 10 seminars, international conferences, etc. He is awarded 2 students for PhD and working 6 students under his valuable guidance. Sir has published a large number of, that is 99 research papers in international journals. And to you know, his citation is about 2029, H index is 25, ITS index is 63. He has been published various his research paper in the very reputed journals, that Science Direct, elsewhere, medical science journals as well as chemical review journals. He has been published books in the synthetic application of organic chemistry journals. He has been reviewed 40 more research paper in of the various journals. So this is his, he is having very broad his area of work as well as his biodata. Because of the time constraint, I will just take it in short. He is very good chemist and researchers. Today he will be delivered a lecture on the occasion of the Nobel Laureate series, lecture series organized by this college. It's the beginning and opening ceremony of the first lecture of Dr. Bapusaheb Shinte for the chemist on Nobel Laureate in Chemistry 2022, particularly on the click chemistry. Before ending my word, I again welcome our senior colleagues and head of the Department of Mathematics, Professor Phasale is with us. So, sir, welcome you all. On behalf of, once again, welcome all the online dignitaries as well as all the dignitaries on dais, all the dais. And with this few words, I'll conclude. Stop you. Thank you all.
यानंतर आपल्याला झूम मीटिंगद्वारे माननीय बापूराव श्रीखंडे सरांचं लेक्चर
Hello, am I audible, sir?
Yes, sir. Yes.
डॉक्टर जरा मला एक तुमचं लेक्चर सुरू होण्यापूर्वी हॅलो ऐकायला येतं ना?
हो, येस सर, येस सर.
म्हणजे ऍज अ फिजिकल केमिस्ट्री स्टुडंट म्हणून थोडीशी माझी क्युरियोसिटी आहे म्हणून मी लेक्चर पूर्ण ऐकणार आहे. कारण बऱ्याचशी मी चांगल्या सरांची केबिनमध्ये बोलताना बोलतोय की ज्यावेळेस आम्हाला प्रोफेसर वाडिया यशवंत सर आणि माली सर त्यावेळेस 5 वर्षला हा ऑर्गॅनिक केमिस्ट्रीचा विषय होता आणि त्या टायमाला आम्ही शिकत असताना म्हणजे माझं केमिस्ट्री बऱ्यापैकी डायव्हर्ट झालं होतं. पण ऑर्गॅनिक केमिस्ट्री मधला हा जो टिपिकल पार्ट आहे की आज आपण 21व्या शतकात आहोत. म्हणजे तरी आपल्यापैकी अनेकांनी म्हणजे केमिस्ट्रीची लोक आहोत आम्ही कसं ऍटम शिकवतो, मॉलिक्युल शिकवतो, पण ऍटम कोणी पाहिलेलं नाही, इलेक्ट्रॉन कोणी फिरताना पाहिलेलं नाही. आणि त्यानंतर आपण बघतो की बेंझिनचं स्ट्रक्चर आहे, ते चेअर आहे, बोट आहे, हेक्सेनचं स्ट्रक्चर आहे, ते कशा प्रकारे आहे आणि त्याला आपण ग्रुप सबस्टिट्यूट करू. त्यावेळेस ते आमच्या फार डोक्यात जायचं स्टॅगर्ड आणि ते त्या सगळ्या गोष्टी आहेत. आणि त्या क्लिक केमिस्ट्री म्हणजे काय की वन फॉर्म टू अनदर फॉर्म मध्ये स्ट्रक्चर्स मध्ये चेंज होणं ही जी संकल्पना आहे त्या काळामध्ये जी मांडलेली गेली होती. त्याच अनुषंगाने आपण पाहतो की आज फार्मा केमिस्ट्री मध्ये की अशा प्रकारची एखादी मोठ्या लेवलची ऑर्गॅनिक मॉलिक्युलची सिंथेसिस करून एखादा अनवॉन्टेड फॉरेन बॉडी असते आपल्या शरीरामध्ये किंवा डिसीजेस असलेले एखादी व्हायरस वगैरे त्याला कॅच करणे हा एक भाग आहे का केमिस्ट्री. म्हणजे मला त्याचं आज्ञान आहे की आणि नोबेल अवॉर्ड मास्टरनी थोडंसं वेगळं पाहिलं तर या संदर्भातली थोडीशी क्युरियोसिटी माझी वैयक्तिक आहे. आणि क्लिक केमिस्ट्रीला ज्यावेळेस अवॉर्ड मिळतो आणि आज आपण बघतो की यामुळे फार्मा इंडस्ट्रीला जे नवीन दिवस आले आणि जागतिक स्तरावर आपण पाहतो आजही ह्युमन रिलेटेड रिसर्च जो असतो त्याला फार वॉन्टेड रिसर्च आहे. आणि म्हणून आमचं जे यंग पब्लिक आहे किंवा यंग रिसर्चर आहे यांनाही थोडस संदेश यानंतर तुम्ही द्यावा. खरं तर मी तुमचं लेक्चर पूर्ण ऐकणार आहे, आमच्या इकडे विचारणार आहे. तर या वेलकम करतो. रिक्वेस्ट टू यू डिलिव्हर युअर लेक्चर. थँक्यू व्हेरी मच.
Okay, shall I start, sir? Kannade sir.
Yes, sir.
Yes. Thank you, Kale sir, for a nice introduction. As well as I am very much thankful to the principal, respected Kannade sir, Anna Sahib Aute College, Manchar, all the vice principals, Dr. Kale sir, Head Department of Chemistry, and all the faculty members from chemistry as well as from other science departments. First of all, I would like to thank and express my sincere gratitude towards the Shinde sir as well as Kale sir for inviting me to such a wonderful session for delivering a talk on click chemistry on the occasion of welcome ceremony of MSc first year by MSc second year chemistry students. As the motto of Rayat Shikshan Samstha, as we know, that is education through self-help, Swavalambanatun Shikshan. And keep in mind these words, how to become a real educators, real learners of the subject. Just I want to make some corrections in the biodata read by Dr. Kale sir. See, as I'm working in the Department of Chemistry at Dr. Babasaheb Ambedkar Marathwada University since 2008. Prior to that, I did my PhD at National Chemical Laboratory, Pune, along with then University of Pune and now Savitribai Phule Pune University, Pune. Means being a student of Pune University, as well as so far we have published more than 120 research articles in the journals of international reputes. And till today, 7 students have received a PhD degree. And out of 7 students, 5 students have worked on click chemistry. This click chemistry, the area which we have started in the year of 2010, means this year on the day of 5th October 2022, Nobel Committee have awarded Nobel Prize in the subject of chemistry for click chemistry. No doubt we will discuss that part later on. In addition to those 5 students, presently 4 students are working on the concept of click chemistry. Means we are not inventors, but we are the followers. Another somewhat corrections just I want to make. As I told you, more than 120 research articles we have published so far, and H index is 32, I-10 index is 92. And I feel proud to be a part of Rayat Shikshan Samsthas. Whenever invitation will come from Rayat Shikshan Samstha, whatever it may be the college, म्हणजे कॉलेज कुठलंही जरी असलं तरी आजपर्यंत मी शक्यतो मोर दॅन 99.9% मी कधीही इन्व्हिटेशन टाळलेलं नाही. आजपर्यंतचा माझा अनुभव हा आहे. मग ते श्रीगोंद्याचं कॉलेज असू द्या, मग ते अहमदनगरचं राधाबाई काळे महिला महाविद्यालय, श्रीरामपूरचं कॉलेज जरी असलं किंवा अण्णासाहेब आवटे महाविद्यालय, SM जोशी कॉलेज, साताऱ्याचं कॉलेज, दहिवडीचं कॉलेज, मिस मोर दॅन 15 to 20 colleges I have delivered a talk either through online mode or offline mode. And I feel proud at small places of Manchar. You are running MSc chemistry from 2010 and you have added one more batch of MSc organic chemistry, means around 50 students are admitted for MSc organic chemistry. And in addition to that, as a need of industry, pharma industry, your college have started analytical chemistry in the year of, I think, 2017 or 19. Means around 80 students are post-graduating in chemistry every year. Means see the value or the strength of chemistry subject as a need of 21st century. Exactly 10 years before, we have celebrated International Year of Chemistry. International Year of Chemistry 2011. See, the slogan for that or the motto of celebrating International Year of Chemistry: chemistry is our life, chemistry is our future. See, everything is made up of by chemistry. From morning to evening, whatever things we are taking or wearing also or using, it becomes by the chemistry. And my dear students, you are the lucky students, have got an admission to MSc chemistry program, whatever it may be the specialization, organic or analytical chemistry. And you have a bright future. You have a bright future, definitely. But you have to perform this MSc chemistry program with some kind of responsibility and seriousness. Seriousness, that is also important. Because if you are not attempting or if you are not doing any kind of experiment in the laboratory or you are not attending the classes, then chemistry will not come with you. And you have to do practice and practice of chemistry. Definitely your future will be bright. See, Dr. Raghunath Mashalkar sir says that if you are taking proper education, quality education, good education, then your future will be bright. Means E is equal to F. Education is equal to future. Whatever chemistry education you are taking, your future will be definitely bright. As you are seeing in front of you, the great academicians, the great teachers are there. After a long time, I have heard words of Dr. Kale sir. He is a good teacher, excellent teacher. See, always motivates to the students, definitely. Not only Kale sir, but other faculty members from chemistry as well as from other subjects. And I know personally each faculty members from, at least from chemistry subject of Rayat Shikshan Samsthas. Yes, even though my subject, I am working at Department of Chemistry, Dr. Babasaheb Ambedkar Marathwada University. That is my first institute, and my second institute is Rayat Shikshan Samstha. Even though I have not studied in Rayat Shikshan Samstha, but whatever things I have learned, I have to transfer to the students of Rayat Shikshan Samstha. We should contribute a little bit to the society, to the institution constituted by respected Karma Veer Padma Vibhushan Bhaurav Patil. With this, we will start the talk on click chemistry, our contribution. Just I will share, as the students of MSc chemistry, definitely, as Kanade sir have already mentioned that regarding the two great teachers of chemistry, then era, until today also, respected Professor R.S. Madi sir and respected Professor M.S. Wadia sir, excellent teachers of chemistry, organic chemistry, and both of them have taught the students of Maharashtra region, and one of this subject, famous subject, or even though just 6 to 7 years before, I have heard the lecture delivered by the Professor M.S. Wadia at Sant Gadge Baba Amravati University, Amravati, on the topic of pericyclic reactions. His very much interested topic. And later on, after his lecture, I have delivered a talk. Some other talks was there. In pericyclic reactions, everyone is studying the cycloaddition reaction. Cycloaddition, 2 plus 2, 2 plus 4 cycloaddition reaction. And the terms diene and dienophile is there. Diene and dienophile, how to generate diene and how to generate dienophile. The reactions were carried out either in the presence of light or in the presence of heat. And accordingly, we are getting 100% 100% atom economy. And that is the important motto of green chemistry, principles of green chemistry. See, even though the concept green chemistry came later on, prior to that, in pericyclic reactions, whatever pericyclic cycloaddition reactions are there, all cycloaddition reactions are 100% atom economy. Based on this particular concept, cycloaddition, Professor Sharpless, K.B. Sharpless, have started work on at the initial stage of 21st century. 21st century means the life of click chemistry is just 22 years. And within this 22 years, the 3 great personalities of the chemistry subject have received a Nobel Prize on the day 5th October 2022. And after 5th October 2022, I am delivering a talk on click chemistry. This is the 15th talk. This is the 15th talk on click chemistry. This is the third talk in Rayat Shikshan Samsthas. Third talk. Okay, just I will share my presentation, and prior to that, we will talk about somewhat. Sir, please allow me. to share the presentation. Please allow me. Hello? Yes. Whether slides are visible, sir? Can anyone tell me? Hello? Slides distat ka? Hello?
Yes, your slide is visible, sir.
Yes, okay, okay. Just, I will do some more exercise. Yeah. Prior to discuss on click chemistry, our contribution in this particular field, as I have told you, we are not inventors, just we are followers of the concept, because the current personality, 3 people are there. And I will tell you what is the chemistry, this particular chemistry later on. But prior to that one, as India is facing a lot of medical issues, and I used to consider the most important diseases of the death in India. Around 10 to 15 different diseases are there. And because of those 10 to 15 diseases, in India particularly, a lot of deaths are occurred. We are reading through newspapers daily, through road accidents, through self-harm, or by other means. A lot of deaths occurs not only in Maharashtra but also whole India. And just I have considered top 10 diseases in India which causes death. First disease, as we are listening about the heart attack, and this is the first cause of death in India. Heart disease related problems. Second one, chronic obstructive pulmonary disease, means related to lungs infections. Lungs infections like that way, chronic pulmonary obstructive disorderness. Then the third disease, that is a diarrhea. As early rainy seasons, many more people are facing the problem of diarrhea, and a lot of types of diarrhea is there. Then brain stroke. Nowadays, many more people, because of brain stroke, the net output in the form of death. And we all have witnessed that if somebody is having a brain stroke, then remaining organs like kidney, liver, heart, eyes, or skins, some of the families are donating to other people's, and by donation of these kinds of organs, other 8 people can survive in better way through brain stroke. Then lower respiratory infections, as we all have witnessed that from last 3 years, at least from March 2020, in India particularly, we are facing a problem of lung infections or COVID-19 pandemic, coronavirus. Okay. Then another important disease, that is a tuberculosis, TB in short. As we know very well, in every villages, not only in 20th century, but in 21st century also, so many people are facing a problem of TB. Different types of TBs are there. Then neonatal preterm birth. See, means if some lady is giving birth to new, either boy or girl, after 9 months, but prior to that, 7 months, 8 months, that kind of childs are also facing some kind of problems. That's why neonatal preterm birth. Then self-harm, as I have told you, self-harm. This is one of the examples, self-harm. Then majority of the deaths occur in India because of road accidents. See, road accidents, we all have seen, we are all are reading. And other problems are also there. Okay, not only these, but also in late 20s or early 21st century, most of the peoples have faced the problem of HIV, AIDS, then swine flu, different types of flus are also there. See, and I will talk on one of the important disease, that is a tuberculosis. This tuberculosis. See, as you may have seen, some of the peoples are having such type of symptoms. It's difficult to see by our eyes, but those who are facing a problem of tuberculosis, they know very well what kind of difficulties they are facing. And what are the symptoms or signs of the TB? If you are facing regularly the problem of fever, or if you are having a problem of night sleeps or night sweats, or cough regularly, or if you are losing weight without any exercise, so this is one of the symptoms. Then loss of appetite, fatigue, these are the symptoms. No doubt there are some medications, vaccination is there, no doubt. But one of the factor how tuberculosis is transmitted from person via droplets, means through cough. And if I am a patient of TB and in front of some other people's, if some cough has come, then through the droplets, whatever infected lung is there, through those droplets, it can be transmitted to the normal peoples also. And if somebody is facing a problem of tuberculosis, definitely some additional problems will be with them. And no doubt diabetes is also one of there, as well as HIV, AIDS. No doubt there are some medications, but till today, in 21st century, third decade, if you have a different type of TB, means normal TB, multi-drug resistance TB, resistance in India, such kind of drugs are not applicable to the patients, then it is called as multi-drug resistance. Definitely my lecture will be totally multidisciplinary, not only chemistry learners, but also biology peoples as well as computer science peoples and pharmacy peoples, definitely. See, this is about just introduction about tuberculosis. And see, as I have told you that this tuberculosis is the top 10 cause of death worldwide, not only in India. And see the data for 2015, 10.4 million people fell ill with TB and around 1.8 million people died from the disease. See the percentage. Means if 10 people are facing a problem of TB, out of 10, 1 will be died. Means around 10%, I can say. Around 10% or more than 10% also. See, over 95% of tuberculosis death occur in low and middle income countries. See, 6 countries account for 60%. And of the total, with India leading the count, means majority of the patients from India, followed by Indonesia, China, Nigeria, Pakistan, and South Africa. Means all these countries are from middle income countries. And see, out of these, India is a leading one. No doubt, the population of India is a more. That's why. But overall, the low and middle income countries, such kind of countries are facing a problem of tuberculosis. Then, no doubt, chemistry is finding solutions to each and every disease with the help of pharmacy, with the help of microbiology, with the help of biochemistry, biotechnology, and other peoples as well. And just I will tell you the journey of different types of drugs used to cure tuberculosis. And the first successful drug for treating TB is a para-aminosalicylic acid. See, para-aminosalicylic acid by Lehman, okay, in 1943. And later on, see, this antibiotic streptomycin was discovered by Waxman and Schultz and have made remarkable progress in the treatment of tuberculosis. Then in 1946, this thiacetazone small molecule is there. And in 1952, this important drug came in the market, that is isoniazid. And see, most of the drugs, structure of those drugs, till today, even though they have discovered 50 years before, 100 years before, their structures are very small. Not a big structures, not a complex molecules. Very small structures, small molecules are there. And this isoniazid till today, even though after 70 years, this particular drug is recommended by the doctors to the patients of tuberculosis. Then pyrazinamide in 1952, in the same year. No doubt this drug is also used to cure tuberculosis. And rifampicin, again another antibiotic, in 1957 has totally changed the strategy of the chemotherapy of TB, because this rifampicin is an antibiotic. And ethambutol in 1961, followed by fluoroquinones, which is a newer macrolide, and rifampicin later on, rifampicin. See, just I will show you the structure, the combination of the drugs. If primary level of TB is there, generally doctors are recommending first line drugs like isoniazid, rifampicin, ethambutol, or pyrazinamide, or the combination of all the four drugs. It's a difficult to take all the four drugs, combination of all the four drugs, and patients will face a lot of problems are also there. Some side effects are also there. This is the first line drug. And second line drug, that is a thiacetazone, para-aminosalicylic acid, ethonamide, kanamycin, and this one, as well as newer second line drugs. All antibiotics are there: ciprofloxacin, ofloxacin, levofloxacin, clarithromycin, azithromycin. Some of the drugs are fifth line drugs, fifth generation antibiotics, sixth generation antibiotics are there. Okay, if patient is suffering from multi-drug resistance, then doctors are recommending combination of first line as well as second line drugs to cure tuberculosis. As well as XDR type of TB is there, total drug resistance TB is there. And if the patient is suffering from total drug resistance tuberculosis, finally, after some time, he will die. Okay. However, I will show you the structures of some of the representative drugs used for treating the tuberculosis. As I have told you, INH, that is isonicotinic acid hydrazide, INH. Okay, INH, isonicotinic acid hydrazide, small drug is there. See, this is the pyridine skeleton for the sake of students, because you are the future of India. Pyridine, small molecule. And on the pyridine at fourth position, that is also important. The position of the substituent is important in organic chemistry. And this acid hydrazide group is at fourth position. If it is at a third position, it is a totally inactive. If it is at a 2 position, again it is inactive. That's why the position of functional groups on the aromatic compound are important. Another heterocycle, see pyrazinamide. This is the pyrazine core, and this is the amide bond is there, small drug. Then higher antibiotics, ofloxacin, kanamycin is also there. And this is a rifampicin. See, this is a macrolide. Ethambutol. See, small molecule, 2 hydroxy group and 2 amine groups, secondary one is there. And see, the experts from tuberculosis, they are saying that this is the recent drug. This is a recent drug based on quinoline moieties. See, those who are working on quinoline, they have a great future, because as we have witnessed that to give the treatment of the patients of coronavirus or COVID, In India, not only in India, but also in US, doctors have recommended that chloroquine or hydroxychloroquine. The purpose of chloroquine and hydroxychloroquine was different. And we have learned, the chemistry people have learned one of the terminology, that is repurposing of the drug. Repurposing. The purpose was different, and later on the purpose was totally different. And this drug can survive the patients of tuberculosis for next 10 years. This is their claim. And definitely sure. Even though till today, many more researchers are working on the design and development of new anti-tubercular agents. New anti-tubercular agents. Okay. Not only this TB, but I will tell you another disease which India is facing a lot of problems in terms of fungal infections. In rainy seasons, we have seen most of the people are facing such type of problems. It is a fungal infection. And there are two types of fungal infections are there. One is a superficial, and which occurs on the legs, hands, or eyes, or on mouth. Such kind of problem some of the people are facing. And this is because of fungal infections. As we have seen, tuberculosis it is a bacterial infection. This is a fungal infection. This is the first type of fungal infections. And second type of fungal infection, see, it's a difficult to see such type of figures, but those who are facing a problem of such kind of disease, how they are facing. This is the second one, systematic fungal infection, Candida albicans, which is opportunistic infections. To cure these fungal infections, different types of drugs are used. Okay, different types of drugs. What are those drugs? Just I will tell you the types of the drugs, category of the drugs. Most of the antibiotics doctors are prescribing, suggesting to the patients of facing the problem of fungal infections, amphotericin B, nystatin, riboflavin. Azole antifungals are there, just representative example. Allyl amines and pyrimidine based some drugs, that is a flucytosine, which is a small drug again, small drug. And I will show you this azole antifungus. As we know very well, if we are facing a problem of our stomach, simple stomach, then usually doctors are recommending us, that is albendazole drug. That albendazole drug, azole particularly, these azoles are synthetic compound. They are not a natural compound. Whatever azoles are there. Okay, and there are two types of azoles are there. Two types of azoles. Imidazole having 2 nitrogens and this triazole having 3 nitrogens. In their structures, imidazole and triazole groups of antifungal drugs inhibit the enzyme cytochrome P450 14 alpha demethylase, which is a fungal enzyme. And this enzyme converts lanosterol to ergosterol. The students of second year, they may have heard about the lanosterol, ergosterol, cholesterol, how lanosterol is converted into ergosterol as well as to cholesterol. C means the biosynthetic pathways for steroids. Biogenesis, we can call it. And Pune University, from last more than 50 years, they are teaching one topic, biogenesis of steroids, biogenesis of terpenoids, biogenesis of alkaloids as well. How they are constructed in the nature. Okay, and is required in fungal cell membrane synthesis. These drugs also block steroid synthesis in humans. As I have told you, two types of azole antifungals. Azole are there. See, imidazole, this is the list of imidazole-based drugs. That is miconazole, ketoconazole, and many more are there. The second type of azoles, that is a triazoles, they are newer, less toxic, and more effective. Example is a fluconazole, itraconazole, rauconazole, ketoconazole, etc. Not ketoconazole, rauconazole, voriconazole, posaconazole. See, these are the two types of azole antifungal agents. One is imidazole based, another one is a triazole based. And just I will show you the structures of triazole based antifungal drugs. See, this is the structure of fluconazole. In their structure, see the ring, towards the ring. This is a triazole ring. 2 triazole rings are there in their structure. And the arrangement of the nitrogen. This is a 1, this is a 2, and this is 3. Sorry, this is 3 and this is a 4. This is a 1-4 triazole. 1-2-4 triazoles are there. Here also 1-2-4 triazole. 1-2-4 triazole. In itraconazole, again it is a 1-2-4 triazole. See, and these triazole-based drugs or compounds are available in the market. Okay. See, now I will switch over towards the Nobel Prize for the year 2022 in the subject of chemistry. And from last 2 years, we have witnessed that the Nobel Prize in chemistry is received by the chemistry peoples. Last year also for synthetic organic chemistry. This year also again for the synthetic organic chemistry as well as somewhat bioorganic chemistry, we can call it. Okay. On the day of 5th October 2022 at 3 p.m. in India, 3 p.m. in India, particularly the time also I am showing to you, the Nobel Prize was declared, and around at 3.02 p.m., I have seen the news. And from morning, I am considering that this year's Nobel Prize should be related to ours. See the feelings of the learners from morning. But I have not thought about it will go for click chemistry. Exactly. But at least that subject or the people should be related to us. And accordingly, on the day, 5th October, the Nobel Prize in Chemistry was given to the peoples on the topic for the development of click chemistry and bioorthogonal chemistry. And the great professors, Professor Caroline Bartrozzi from Stanford University, USA, Professor Morten Meldal from Copenhagen University, Denmark, and K. Barry Sharpless from Scripps Research Institute, USA. These 2 USA peoples from the same state, that is California, Stanford University, California, in the same state, and Scripps Research Institute is also in California. These 3 peoples have received a Nobel Prize for the development of click chemistry and bioorthogonal chemistry. Okay. And you may have seen on the 5th October as well as in 6th October, most of the chemistry peoples have kept their status of these 3 peoples. And different photographs may be there. And for their contribution, they have received a Nobel Prize. Now, we will see. On 6th October, particularly in India, or late night of 5th October, you may have seen again the status of this picture. See, Professor Caroline Bartrozzi, Michael Meldal, and Sharpless for the development of click chemistry and bioorthogonal chemistry. First of all, the person, this is a Sharpless. He has coined the term click chemistry in the year of 2001. First time he has given the terminology. This is the somewhat a terminology, the word click chemistry, to the Society of Chemistry. First time, Sharpless have coined the concept of click chemistry. And meantime, Meldal was also working on this particular cycloaddition reaction. Parallelly, we can call it parallelly. Okay. Parallelly in Denmark. And this Bartrozzi in 2002 have started working on bioorthogonal reactions. I will tell you the term bioorthogonal chemistry or bioorthogonal reactions was coined by the great professor, Lady Caroline Bartrozzi. And this is the term related to biological system. Now, in short, I will tell you what is click chemistry or what is a click reaction. This click reaction is nothing but a reaction of terminal azide and a terminal alkyne in presence of copper catalyst in some solvent, it gives regioselectively 1,4 disubstituted 1,2,3 triazose. And this particular reaction is given by Professor Meldon and Professor Sharpless. And see what Bertrozzi have done. Bertrozzi have considered here in place of copper catalyst. See, in place of copper catalyst or metal free, I can tell you metal free, C has carried out reaction in the living systems, and very few reactions are there to carry out living system. Living system means some part or one starting material from chemistry and another starting from living system. When coupled to each other, without any metal, without any catalyst, means some part is related to biology, and that's why Professor Bertrozzi have given the term bio-orthogonal chemistry. And this is the extension of click chemistry. I will show you in other parts. See, as I have told you that this is the terminal azide, N double bond, N, positive charge, negative charge, or you can write N3, this R group is there, N3, plus some kind of alkyne. This is the organic part, and this is a C triple bond, CH is there. And there is a reaction between this azide and this alkyne, by using copper catalyst. It gives 1,4, as this is the 1, 2, 3, 4. At 4 position, this the organic part from alkyne, and this one from azide part. This is the organic part. It gives 1,4 disubstituted 1,2,3 triazose. What Bertrozzi have done? Bertrozzi again have taken azide. This is azide, and this is some biological system, glycan we can call it. And in place of open chain alkyne, Bertrozzi have taken cyclic alkyne. Means I can draw C triple bond C, and this is some kind of cyclic system is there. Means no terminal alkyne, it is an internal alkyne, and we have this kind of azide without any catalyst, not a copper catalyst. It gives again this kind of 1, 2, 3 triazole. This is the contribution made by the Bertrozzi, and the term that is a bio-orthogonal chemistry. Bio-orthogonal chemistry is coined by Bertrozzi, and click chemistry term was coined by K. Barry Sharpless. See how these reactions takes place. Consider this is a terminal azide and this is a terminal alkyne part. When they came to closer, just 1 minute. Sir, मी lecture देतो, मी तुम्हाला फोन करतो सर, फोन करतो. Okay. When azide and alkyne in presence of copper catalyst, when come to each other, the role of copper is to activate alkyne. To activate the alkyne, when they came to each other, like see, this type of reaction, this type of some noise is coming. It's nothing but click. It's nothing but a click. And formation of such type of, see here, bond formation takes place in the form of triazole. This part from alkyne and this part from azide. In short, I will tell you, this is the 5th person, K. Barry Sharpless, received a second Nobel Prize in chemistry. In chemistry. See, in the year of 2001, he has received a first Nobel Prize for his contribution in terms of asymmetric. See, as we are teaching his contribution, asymmetric epoxidation. Okay, asymmetric epoxidation of allylic alcohols. And we are giving the term Sharpless asymmetric epoxidation. Sharpless asymmetric epoxidation. In addition to this, Sharpless asymmetric dihydroxylation. Okay, by using osmium tetroxide, salts of osmium tetroxide, and some ligands are also there. Okay, quinidine-based ligands are also there. Sharpless asymmetric dihydroxylation, sharpless asymmetric amino hydroxylation reaction of alkenes. And for this contribution, he has received a first Nobel Prize for the year 2001. And for his contribution in click chemistry, again, he has received a Nobel Prize for the year 2022. Means within the 21 years, he has received another Nobel Prize. And fortunately, most of the Indians have worked with him, Sharpless, worked with him as a postdoc fellow, as a PhD fellow as well. Means we should feel proud being an Indian. Our colleagues, our friends, our senior teachers have worked with him. Not only has they have worked with Sharpless, but also Sharpless have visited India. Okay. See, now in short, I will tell you the click reaction. As I already mentioned, the terminal azide reacts with the terminal alkyne in presence of copper catalyst, formation of 1,4-disubstituted 1,2,3-triazoles. The click chemistry is a simple name. It's a simple name for a simple set of reactions. It is not a named reactions. Students, my dear students, it is not named reactions. But later on in future, it may be given like Sharpless asymmetric epoxidation, Sharpless click chemistry reaction. We hope so. Okay, the core of this click chemistry concept is the cultivation of small set of reactions. It's small substrates, small set of reactions that are extremely ideal for working with organic molecules. And Sharpless described them in his famous 2001 paper in the Journal of Anglo-Chem International Edition. This is the paper. This click reaction would be modular, having wide in scope, means whatever functional groups may be present on this alkyne part or on the azide part, they remains intact. Under these reaction conditions, these remaining functional groups or remaining substrate does not affect. That's why wide in scope gives very high yields. Very high yield means more than 80-90% reaction takes place. Generates only inoffensive byproducts. Okay, only inoffensive byproducts and can be easily removed. See, B stereospecific means if some substrate accordingly are there and requires simple reaction conditions. As we have seen, only it requires copper sulfate, and which is available in the postgraduate laboratory. Okay, and see, one can make azide, one can make alkyne easily. See, required readily available reagents and starting materials, readily available. And I will show you later on. Requires no or benign solvent or easily removable solvents. Means this particular reaction is carried out either in THF water, tertiary butanol water solvent system. Okay. In addition to this, somebody can use PG as a solvent also. Okay. Or sometimes there is no need of organic solvents. Only water can work. And even though people have published their work without using any kind of solvent, means just microwave assisted reactions people have carried out. Okay. Required simple product isolation and purification, no column chromatography, no flash column chromatography. Means if your substrates are solid, then accordingly you can separate by means of crystallization itself. Gives product that are stable in physiological conditions. See, the product is highly stable under acidic or basic conditions. As I have told you that this reaction is 100% atom economy. Whatever starting material is there, it is consumed and gives 100% product. See, and have a high thermodynamic driving force more than 20 kilocalorie per mole. This is a simple reaction. Just I will tell you the journey of click chemistry, the work. As I have told you, the first publication came in 2001 by K. Barry Sharpless. And this concept is totally dependent upon the Hussein's dipolar cycloaddition reaction. Hussein, prior to Sharpless, this cycloaddition reaction pericyclic reactions, usually have carried out such kind of reactions, but without using catalyst, or there are some kind of difficulties was there. The first paper in the year of 2001, but see in 2010, the number of papers was 753. Means how it is slowly increased, the number of publications. And I know this concept from the year 2002. That time I was a research scholar at NCL Pune. And we have started this particular concept from 2011 itself, from 11. Just our initial point on working on independently. And see, in the year of 2020, the total number of publications was, for the year, 1,371. For the year 2021, 1,300. For 2022, 1,081. Till one month is there. And for the year 2023, 25 papers are there. And total number of papers, see, on click chemistry, using click chemistry approach, design and development of new triazoles, or to study their therapeutic or physical properties of the molecules. The total number of publications is 18,665, and this is the data of Scopus on the day November 21, just 10 days before data was there, at 10:45 a.m. See the scope of this particular work. See, as I have told you, the triazole based 1 to 4 triazoles. Here, 1, 2, 3 triazole based compounds are there. This is a 1, 2, 3 triazole structures. And this is one of the drug, that is a CAI in short we used to call. Then TSAO is another drug having the skeleton 1, 2, 3 triazole. These are the potential pharmaceuticals. Here also, cefatriazine, the drug having such kind of 1, 2, 3 triazole system, and the antibiotic tazobactam antibiotic. Okay. Having a beta-lactam skeleton in their structure, beta-lactamase inhibitor. This particular drug is a beta-lactamase inhibitor, and in their structure, 1, 2, 3 triazole is there. And after seeing such type of active molecules, not only these, but also some of other molecules, they are in clinical trial phase 1, 2, and 3. In future, we will see many more drugs will come in the market having a 1, 2, 3 triazole skeleton. Okay. As having a lot of applications, not only in synthetic organic chemistry, medicinal chemistry, material chemistry, as well as biological chemistry or pharmaceutical chemistry. See, being the chemistry learners, we will see either therapeutic properties or some physical properties or some other properties also. This click chemistry approach is used not only in synthetic organic chemistry, but also in material chemistry, in pharmaceutical chemistry, in biological chemistry. And see the applications of 1, 2, 3 triazole based compounds. They are showing anti-HIV activity, anti-inflammatory, anti-hepatitis, anti-diabetic, antibacterial, anti-tubercular, antifungal, as well as anti-Alzheimer and anti-cancer activities. Okay. On the basis, as I have told you that these triazoles are used not only in medicinal, organic, drug discovery, bioconjugation, as well as biomedical imaging and in material science. Now, I will share with you what is our contribution, small contribution. The word is a tiny, means a small contribution towards click chemistry. As I have told you, from 2012, we are working on the concept of click chemistry, and we have contributed a small 0.01%. Small contribution is there. Okay, less than that also. And just I will tell you how we have designed the molecules, small molecules, not a complex molecules, how we have designed. See, this is the first molecule we have designed having 1, 2, 3 triazole skeleton, and the substitution is at 1 position as well as at 4th position. 1, 2, 3 triazoles. This is the aromatic part. This is also aromatic part, but which is connected to ethereal linkage is also there. And as we have seen, triazole backbone shows a drug-like properties. And many more researchers have utilized such type of triazoles in material science also, in coordination chemistry also. Okay, we have designed the molecules and docked the molecules against the enzyme of DPRE1 enzyme, which is used for anti-TB. Okay, anti-TB, we have designed the molecules and synthesized it very well. We have maintained one of the important aspects of designing the molecules. The starting materials which are required to make such type of molecules should be available in the postgraduate laboratory and can be easily made. Okay, accordingly, we have synthesized from the commercially available phenols. See, phenol, simple phenol, metacresol, paracresol, orthocresol, nitrophenols, chlorophenol. These phenols were subjected on alkylation reaction by using propargyl bromide, the name of this one, in presence of mild base potassium carbonate in DMF at room temperature. It gives this type of terminal alkyne. And such kind of derivatives we have made. We have a terminal alkyne and another substrate we need is terminal azide. Azide we need. Now this terminal azide we have made from corresponding bromo or benzyl bromide. These are benzyl azides. We are made from benzyl bromide via nucleophilic substitution of sodium azide. These bromides are made from corresponding benzyl alcohols via substitution of PBr3, or you can use HBr also. HBr, just simply substitution reaction. And these benzyl alcohols are made from corresponding aromatic aldehydes which are available in PG lab. No any specific chemicals were used over here. Only specific chemical is a propargyl bromide. Okay. Now we have two starting materials in our hand, and with the help of click chemistry approach, reaction between this terminal azide, there's a terminal alkyne, and this terminal azide in presence of copper acetate in tertiary butanol water solvent system at room temperature for 19 to 20 hours. Means you can put this reaction at Muncher also. There is no any safety issues. But while preparation of this azide, you have to take care somewhat. Okay, you have to take care. It gives a ratio selectively 1,4-disubstituted 1,2,3 triazose, and see the number of molecules, the library of molecules. Means this 5 and is there, means how we have made 35 new compounds. All are new. And I will show you the structures of all these new 35 compounds. See different types of substitution on benzyl azide part in the form of nitro. Here on phenolic part, that is a methyl group. Like different types of phenols like a trichlorophenol we have used, or chloromethyl phenols also. Nitro group, chloro group is there. Different types of substitutions, bromo. Okay, such type of substitution, and we have made the triazole ring over here. And the yield is more than 95% isolated yield. See, means just by means of crystallization, we have purified the compounds. And after synthesizing such type of molecules, we have well characterized by means of physical properties as well as spectral analysis, IR1, second one, H1 NMR, third one, just I will tell you for this series, C13 NMR, as well as a mass spectroscopy like HRMS. And after synthesizing and characterization, we have screened all these compounds or evaluated all these compounds against the TB strain, that is MTBS37RA, as well as antioxidant activity. And these are the data for the compounds. These are the number, and this is the MIC value. And see, some of the compounds are showing lower MIC value as well as a lower IC50 value against the standard drug, that is a rifampicin. See, the red data is showing the lower values for antioxidant as well as anti-TB activity. See, this red, even though some of the compounds are showing less than 1 MIC value or IC50 value. See here, 0.9, 0.8, 0.2, 0.8 microgram per ml for anti-TB as well as for antioxidant. See the value 11.4 or 10.9, 12.1, 11.0 for antioxidant activity. See, means some of the representative compounds are showing better anti-TB as well as antioxidant activity. And the most active compound, we have docked against the active site of DPRE1 enzyme and showing excellent interactions with the different amino acids. Our synthesizer compounds are showing excellent interactions with the enzyme or with different types of amino acids. And see, these are the most active compounds with the lower MIC value for TB as well as a lower IC50 value for antioxidant activity. And all these synthesizer compounds were studied for their toxicity against these three cell lines, and none of the compound is toxic, as well as we have analyzed for some pharmacokinetic data, like in the form of in silico ADME properties and showing better interactions. And this particular work was published in the year of 2015 in the Journal of Medicinal Chemistry Communications. This is our first attempt. And in our second attempt, just I will go fast now. In our second attempt, the phenol part is the same. We have kept constant. Means the alkyne part kept constant. Just we have changed the azides in place of benzyl azides. We have considered amide-based azides. This is the only difference. And accordingly, as we know how to make this terminal alkyne, then we have made this type of amide-based azides from corresponding anilines on chloroacylation. See, chloroacylation followed by substitution with a sodium azide, which gives azidoamides. And once this terminal azide in our hand, this terminal alkyne in our hand, and after optimization of reaction condition by using copper acetate, and in place of solvent, we have used here ionic liquid as a medium. Okay, not catalyst. The catalyst is a copper acetate and gives excellent yield of the product with these optimized reaction conditions under ultrasound irradiation at 30 degrees Celsius for 35 to 40 minutes. In earlier case, it requires 20 to 28 hours. See, we have reduced the time as well as we have made some new compounds over here. See, the number of compounds are more than 24. And these are the structures. And we have incorporated this amide part. And these are the structures well characterized by means of spectral data and screen for their antifungal activity against different fungal strains. See, different fungal strains like Candida albicans, then Aspergillus niger, then Cryptococcus neoformis. These are the strains. And the red data, is showing excellent MIC value, either twofold or equivalent activity as compared to the standard drug of fungal antifungal drug, that is the miconazole. And none of the synthesizer compound is showing anti-TB activity. See, only two compounds are showing somewhat anti-TB activity, but not acceptable data. As well as we have screened these compounds for anti-tubercular activity, and some of the compounds are showing excellent antioxidant activity, against the standard drug, that is a butylated hydroxytoluene, which is a commercially drug. As these compounds are showing better antifungal activity, that's why we have doctored the compounds against the fungal strains of Candida albicans, larosterol 14-alpha demethylase, and showing better interactions. And this particular work we have published in the journals of RSC Advances, more than 4 impact factor for this journal. See, in our next attempt, we have designed the molecules having a simple skeleton. Just in first case, we have seen the whole skeleton. See over here, this skeleton we have seen. But just we have introduced one acyl group over here. Means the ketone group is there. And such type of functional group, which is very much useful to make n number of molecules, billions of the compounds. If you have acetophenone, then you can make n number of chalcones, n number of other compounds also, and further utilization may take place. See, we have designed the molecules based on we have docked the molecules against the sterol 14-alpha demethylase inhibitors. As we know, this ketone functionality is various bioactive compounds is there, and remaining part which we have seen. And see the synthesis from commercially available phenols. 3 phenols we have considered. 3 phenols we have considered, which are acylated in presence of acetic anhydride pyridine, which gives acetate derivative, which on Fry's rearrangement, as we are doing regularly in PG, Fry's rearrangement on 2 of the alcohols, which gives orthohydroxyacetophenone moiety. Here substitution is methyl and parachlorophenol, means 2 phenols we have subjected and 1 orthohydroxyacetophenone is commercially available. Means whatever this orthohydroxyacetophenone students have made, just we have collected and purified once, twice, and used it for making some beautiful molecules. See, this orthohydroxyacetophenones on alkylation by using propargyl bromide and potassium carbonate resulted into the terminal alkane having this ketone, and already synthesized the benzyl azides in presence of copper acetate tertiary butanol water at room temperature for 20 to 30 hours. We have made 1,4-disubstituted 1,2,3-triazoles having this ketone facility. These are the 18 compounds and the structures are like this way and characterized very well and screened for their antifungal activity as well as antioxidant activity, and some of the compounds are showing equivalent antifungal as well as antioxidant activity. See, the value is 14.14 and the standard drug is 16.14, means our synthesized compound is showing better antioxidant activity as compared to the standard drug. See, these compounds are showing better antifungal activity. The 2 compounds we are docked, not 2, but all compounds we are docked, but these are the most active compounds and showing better interactions with different types of amino acids of steroid 14 alpha demethylase. Okay, and these are the most active compounds with a lower MIC value for antifungal activity as well as lower IC50 value for antioxidant activity. And this particular work, which we have published in the Journal of Chinese Chemical Letters, having impact factor more than 9. See, in our next attempt, in place of phenol, simple phenols, we have considered why not to have a coumarin based phenols. Here phenolic OH group, here phenolic OH group, and here phenolic OH group. See, and why not to make a corresponding alkyne? Is 3 coumarin moieties we have considered, because coumarin you will see in many more drugs, coumarin moiety is there, and we have designed the molecules against the enzyme DPRE1 enzyme for anti-TB as well as steroid 14 alpha demethylase for antifungal. And in our first attempt, see, as we are doing regularly synthesizing this 7-hydroxy 4-methyl coumarin via Pitchman condensation reaction. Pitchman, as students of BSc or MSc, they knows very well. This is commercially available resorcinol on reaction with ethyl acetate in presence of sulfuric acid. Within 30 minutes, we will get 7-hydroxy 4-methyl coumarin. And we have around 35 students for organic chemistry, and every student is making 1 gram every year in regular practical. Means 35 grams just we have collected and purified once by using crystallization and used it for making this particular alkyne. We have 1 alkyne having coumarin skeleton. We have already synthesized the benzyl azides in presence of copper acetate, resulted into the 1,4-disubstituted 1,2,3-triazole having one of the pharmacophore coumarin. We have incorporated 2 pharmacophoric groups in a single molecular motif, gives coumarin based of 1,2,3-triazoles. In another attempts, this 4-hydroxy coumarin, which we can make in laboratory easily or commercially available. Accordingly, we have made another coumarin based alkyne, and on further reaction with this type of benzyl azides gives corresponding coumarin based 1,2,3-triazoles. And these are the structures very well characterized by means of spectral data and screen for C, anti-tubercular activity, antioxidant, antibacterial, as well as antifungal activity. And C, the compounds are showing excellent anti-tubercular activity. Some of the compounds are showing antioxidant activity, and almost all compounds are showing excellent antibacterial as well as antifungal, equivalent or 2-fold or 4-fold activity also. See, equivalent means if MIC is a 4, here some of the compounds are showing 4 MIC, here 16 MIC, some of the compounds are showing 4 microgram per ml, means our compound is a 4-fold active. See over here, 4 MIC value against this 10, here 2 MIC value is means 2-fold active. And We have talked these compounds against the DPRE1 enzyme for anti-TB and showing better interactions with amino acids. And these are the most active compounds for TB, for antioxidant activity, as well as for antimicrobial in the form of antifungal and antibacterial. This particular work we have published in the Journal of Medicinal Chemistry Research. See, in another attempt, another coumarin-based compound we have synthesized from commercially available resorcinol via Wills-Meyer-Huck formulation reaction. The students of BSc as well as MSc, they are studying theoretically, but practically, why not to make some another salicylaldehyde? This is a salicylaldehyde, and we have introduced this formyl group at ortho position with respect to any one of the OH group by using Wills-Meyer-Huck formulation, followed by novel condensation by using diethylmalonate, and cyclization leads to this is 7-hydroxy, this 7-hydroxy coumarin derivative, which on propargylation by using propargyl bromide, followed by copper catalyzed click reaction with the benzyl azides resulted into the coumarin-based 1,2,3 triazose. And these are the structures well characterized and screened for their antifungal activity as well as antioxidant activity. And some of the compounds are showing equivalent antifungal as well as antioxidant activity. As we have talked these compounds against the strain of 14-alpha demethylase and showing better interactions with amino acids. And these are the most active compounds for antioxidant, antifungal activity. And this particular work, which we have published in the Journal of Chinese Chemical Letters, having an impact factor, just I have told you 9. See, here we have used a simple benzyl azides. See, simple benzyl azides. Now, we have changed the benzyl azides. And the alkyne-based starting materials we have kept constant. See here, amide-based azides we have used. And the 2 coumarin starting materials we have designed and synthesized these type of compounds, as we already seen how to prepare this one, alkyne, terminal alkyne, and how to prepare this one. Just we have made this type of azides which already prepared. Just we have changed the starting material, coumarin-based 2 starting materials, and these amido azides on click reaction by using copper acetate in tertiary butanol water solvent system at room temperature for more than 20 hours resulted into the coumarin-based. This is a coumarin skeleton. This is a triazole, coumarin-based triazoles having amide moiety. Amide moiety means see the structures of all these amide, triazole, and coumarin. Means 3 pharmacophoric groups in a single molecular motif, and with the help of molecular hybridization approach, we have designed, synthesized, characterized, and evaluated for antifungal activity. And the data, red data is showing excellent antifungal activity, as well as none of the compound is showing anti-TB. One compound is showing, and one compound is showing antioxidant activity, docked against the cytochrome P450 fungal enzyme, and showing better interactions. This particular work is published in the Journal of Arch Pharma, having more than 4.5 impact factor. See, so far we have seen phenol-based alkynes. Here, this isatin, this is the isatin backbone. You will see in many more drugs, and we have incorporated this isatin in our design. Designed the molecules against the enzyme, that is the cytochrome P450. And synthesized from commercially available isatin. One isatin is there on propargylation by using sodium hydride. We have this one alkyne. We have already synthesized the benzyl azides in presence of copper acetate, resulted into the corresponding isatin incorporated 1,2,3 triazose. In our another attempt, this isatin-based alkyne and aryl azides we have directly prepared from commercially available anilines by diazotization followed by substitution with sodium azide, resulted into the isatin-based 1,2,3 triazoles. These are the compounds characterized very well and screened for their anti-TB activity, antioxidant as well as antifungal activity, and showing excellent activity docked against the cytochrome P450 14-alpha demethylase. And these are the most active compounds for antifungal, anti-TB as well as antioxidant. And none of the synthesized compounds is toxic against the cancer cell lines, that is HeLa, A54 and PAN1C, and analyzed for ADB property. This particular work is published in the Journal of Heterocyclic Chemistry. In our next attempt, just we have changed one of the pharmacophoric group, that is benzthiazolone, which is available in many of the drugs, incorporated this triazole, and this particular triazole showing anti-TB activity, which we have seen already, and the synthesis C, orthoaminothiophenol on reaction with chloroacetic acid in presence of sodium acetate resulted into the benzthiazolone. Now we have a pre-NH group treated with the propargyl bromide in presence of base resulted into the terminal alkyl. And we have already synthesized the benzyl azides and one benzothiazine based alkyl in presence of copper acetate resulted into the benzthiazolone based 1,2,3 triazoles. Again, this benzthiazolone based alkyl on reaction with aryl azides, which we are already prepared, resulted into the corresponding 1,2,3 triazoles. See, these are the structures characterized very well and screened for their anti-tubercular activity against the two strains of TB, MTBS37RA and M-bovis BCG, as well as antioxidant activity, and some of the compounds are showing excellent activity and docked against the DPRE1 enzyme and gives better interactions. And these are the most active compounds, and none of the compound is toxic against these cell lines. And also we have studied ADME properties, and this particular work is published in the Journal of Bioorganic and Medicinal Chemistry. See, benzthiazolone we have used in our next atom. This is the skeleton thiazolidinone. See, thiazolidinone, this thiazolidinone backbone you will see in many more anti-diabetic drug, as well as this thiazolidinone scaffold showing anti-inflammatory activity as well as antimicrobial activity displayed by use of triazole. See, we have introduced this triazole on this thiazolidinone moiety. We have designed such type of molecules and synthesized from aromatic aldehydes. Only 3 aromatic aldehydes we have considered here. That is benzaldehyde, fluorobenzaldehyde, and chlorobenzaldehyde. Treated with a thiazolidinone via novel condensation in presence of sodium acetate resulted into the arylidine thiazolidinone. Now we have free NH group alkylated by means of propargyl bromide gives these 3, which on reaction with benzyl azides, which we have prepared already, 5 benzyl azides, 3 alkynes in presence of copper acetate resulted into the 15 thiazolidinone based 1,2,3 triazoles. See, these are the structures well characterized by means of spectroscopic techniques and screened for anti-inflammatory activity. First time I am introducing this anti-inflammatory activity. The standard drug is the diclofenac sodium having EC50 values of 0.72 and our synthesized compound 0.84 means equivalent activity. Here 0.6 means better anti-inflammatory activity, 0.70 again better inflammatory activity, as well as 0.8 better anti-inflammatory activity, as well as some of the compounds are showing excellent antioxidant. However, none of the compound is showing anti-tubercular activity. We see the specificity against the anti-inflammatory. In addition to that, we have screened these compounds for antibacterial against the 3 gram-positive bacterial strain, gram-negative bacterial strain 3, as well as the 5 strains of fungi, and showing excellent antibacterial as well as antifungal activity against the standard drug, that is amphotericin B, then ciprofloxacin, mycorrhizal, and as well as a fluconazole. Such type of drugs, standard drugs we have used and docked against the enzyme because this synthesized compound is showing better anti-inflammatory activity. That's why we have chosen the enzyme that is PPAR gamma and showing better interactions. And these are the most active anti-inflammatory drug, anti-inflammatory compound with a lower MIC value as well as antioxidant activity and antimicrobial activity. Friends, I will tell you, on this particular chemistry, we have published one Indian patent. We have published one paper in the Journal of Polycyclic Aromatic Compounds on anti-inflammatory and on antimicrobial activity. We have communicated one more paper in the standard journal again. Means one system, 3 publications are there. See, in our next attempt, what we have done? We have made some kind of hydrazole having a triazole skeleton over here. Triazole skeleton. And the hydrazoles derived from INH, which is a standard drug, that is isonicotinic acid hydrazide, then nicotinic acid hydrazide and parachloro or paramethoxy benzoic acid hydrazide. See the studies, see the structure activity relationship. As you are the students of post graduation, you are studying medicinal chemistry in organic chemistry, and you will learn such type of structure activity relationship. See, in this case, we have used a commercially available para-hydroxybenzaldehyde in our first atom. We have alkylated over here, and we have already synthesized the benzyl oxides. On click reaction, we have a triazole and we have a free aldehyde group. And we have utilized this free aldehyde group treated with a different types of acid hydroxides of INH, nicotinic, as well as para-nitrobenzoic acid hydrazide in presence of methanol and catalytic amount of acetic acid at a room temperature resulted into the corresponding hydrazoles. These are the 12 compounds. Okay, these are the structures. And see the activity data. See the red data for INH based isonicotinic acid hydrazide based, which is a drug, direct drug, showing excellent anti-TB activity. See here, against the 2 TB strains, as well as excellent antioxidant activity. Similarly for compound number 20D, 20G, and 20J. Not only anti-TB, but also antioxidant activity. Equivalent anti-TB activity as compared to standard drug, that is rifampicin and INH. Okay, and we have talked these compounds against the DPRN1 enzyme and showing better interactions, and these are the most active compounds. Okay, most active compounds, and none of the compound is toxic against the cell lines, cancer cell lines, as well as we have studied ADME property, and this particular work is published in the Journal of Mini Reviews in Medicinal Chemistry, having impact factor more than 3.5. In first case, we have taken para-hydroxybenzaldehyde. In second case, we have taken salicylaldehyde. Only 2 compounds. One is salicylaldehyde and another one is a bromo-substituted salicylaldehyde. Under similar reaction condition, we have alkyne, we have benzyl azide, and we have made this triazole-based aldehyde treated with a different 5 types of acid hydroxides. Again, INH, nicotinic, paranitro, parachloro, paramethoxy. And in presence of methanol, catalytic amount of acetic acid at room temperature resulted into this hydrazoles. These are the hydrazoles, triazole-based hydrazoles, and these are the structures. Around 40 compounds are there, and the structures of all these synthesized compounds were confirmed by means of spectroscopic techniques and screened for their anti-TB activity as well as antioxidant activity. See the data. 24A compound is INH based, 24B nicotinic acid, 24C nitrobenzoic, 24D paramethoxybenzoic, and 24C parachlorobenzoic acid. Means remaining acid hydroxides based hydrazoles are not active. Only INH based hydrazoles are active. See over here 24K, 24P, as well as 24E, 25A, and 25M and 25H. We see the red data is showing excellent anti-TB activity. Excellent anti-TB activity. And these are the most active compounds with lower MSc as well as IC50 value, as well as none of these synthesized compounds is a toxic against the cancer cell lines. And this particular work just we have communicated to the Standard Journal of Medicinal Chemistry. In our next attempt, why not to incorporate tetrazoloquinolin? Because quinolin we know very well, having a lot of drugs in the market, and why not to introduce this triazole moiety and see the chemistry. This commercially available meta-anisine on acylation gives acetaldehyde on Wilsberg formulation reaction resulted into the 2-chloro-3-formyl-quinolin. See, the nucleophilic substitution with sodium azide resulted into the tetrazoloquinolin aldehyde. Reduction by means of sodium borohydride, methylation by using methane sulfonyl chloride. We have this leaving group on treatment with sodium azide resulted into the azide which we require. This is a multi-step organic synthesis. But it requires only 15 days. If you start from today, in your hand, after 15 days, this azide will be there. And we have only one azide, and we have already synthesized this type of terminal alkynes from phenol. Under click reaction condition, we got such type of tetrazoloquinolin based triazoles And to compare the activity, in place of this ethyl alkyne, we have taken commercially available phenylacetylene and made this type of compounds like 23I. Okay, see, these are the structures. And see, the compounds, our synthesized compound starting material is not showing any kind of antibacterial as well as antifungal activity, but our synthesized compounds are showing equipotent activity against the fungal strain as well as a bacterial strain. Okay, and we have talked about these compounds against the fungal strain, that is sterol 14-alpha demethylase, and these are the most active antifungal as well as antibacterial compounds. And this particular work is published in the Journal of Polycyclic Aromatic Compounds. In our next attempt, see, so far we have seen how to make monomeric triazoles, how to introduce only one triazole ring in the structure, having some pharmacophoric groups, different types of pharmacophoric groups. And now in our second attempt, just I will show you the initial point of our synthesis of some dimeric triazoles. Dimeric triazoles, 1, 2, 3 triazoles via chemistry approach, and our triazoles will be like cytosymmetry, like a human body. See, we have designed the molecules. These are the triazoles, one triazole, another triazole, and have some linker over there and having some substitution towards this side. Towards this side, accordingly, we have designed the molecules and synthesized them very well from the commercially available phenols. That is resorcinol or catechol, which is available in PG lab, which on alkylation by using propargyl bromide K2CO3. This gives catechol derived dialkyne, and this one is resorcinol derived dialkyne. And we have already synthesized amide based azides treated with each other, C6A and 6B. The azides are the same. The alkynes, 2 alkynes, which we have freshly prepared, on click reaction resulted into the bis triazoles or dimeric triazoles over here. And these are the dimeric triazoles having amide linkage. These are the structures of all these triazoles, well characterized by spectroscopic techniques and evaluated for anti-TB activity. And see here, the bold data is showing good anti-TB activity, 2 compounds. Then we have further screened for antifungal activity against the 4 fungi strain, and the bold data is showing excellent antifungal activity as compared to the standard drug. Just I'm marking some, as well as some of the compounds are showing excellent antioxidant activity. See, excellent antioxidant activity over here, as well as the same compounds we have screened for their anti-proliferative activity, means anti-cancer activity. And only 10 compounds we have screened for anti-cancer activity, and the standard drug is here having the value IC50 value and IC50 value in micromolar level. The standard drug is showing 2.97. However, our synthesized compound is showing lower IC50 value, that is 2.8 nanomolar level. And these most active compounds are also studied for their percentage EGFR inhibition study, and our synthesized compounds are showing better EGFR percentage, not excellent, but good percentage EGFR as compared to the standard drug. See, I will tell you over here, these are the most anti-cancer, showing most anti-cancer activity or anti-proliferative activity. This compound is showing most anti-TB activity, and these are antifungal, and these are antioxidant activity. I will tell you on anti-cancer activity or anti-proliferative activity, we have made one publication in the Journal of Bioorganic and Medicinal Chemistry Letters. On antifungal activity and 14-alpha demethylase study, we have made another publication in the New Journal of Chemistry, having impact factor more than 3.8. And the third publication on antioxidant activity in the Journal of Research on Chemical Intermediates, having impact factor 3.1. See, these are some docking images as well as in our next attempt, just we have taken the same alkyne over here, either resorcinol or catechol base. Just we have changed the azide part. See over here. See, these alkynes, which we know very well, the azides are derived from secondary aliphatic amines. Secondary aliphatic amines, and we have synthesized by using click chemistry approach. See the amines, that is pyrrolidine, piperidine, dimethylamine or dimethylamine, as well as a morpholine. Chloroacylation followed by azidation reaction. We have made such type of derivatives of dimeric triazoles and screen for their anti-TB activity. See, some of the compounds are showing anti-TB activity as well as antifungal activity, equivalent antifungal, as well as excellent antioxidant activity against the standard drugs, and docked against the respective enzymes for antifungal activity, that is sterol 14 alpha demethylase, and showing better interactions. And this particular work is published in the Journal of Heterocyclic Chemistry. See, again, just we have changed the spacer over here. In place of resorcinol or catechol, we have introduced one of the important skeleton scaffold, that is a piperazine. Piperazine based on dimeric triazoles, and how we have maintained the C2 symmetry over here. See, this is the piperazine, and we have two NH groups which are on dialkylation by using propargyl bromide, and we have already synthesized the azides in our hand. And click chemistry approach resulted into the amide based as well as piperazine based 1, 2, 3 triazoles. Okay, and these are the structures of all these, and well characterized by means of spectroscopy and screen for their anti-TB activity, and the bold data is showing excellent anti-TB as well as excellent antifungal activity and antioxidant activity. See over here the bold data, equivalent antioxidant or more potent antioxidant activity displayed by our synthesized compound, and talked this one against the enzymes and showing better interactions, and this work which we have published in the Journal of Synthetic Communications. Before ending my lecture, I am very much thankful to the principal as well as the coordinators or faculty members from Anna Saheb Avte College have given me an opportunity on this particular occasion of MSc first year students for their welcome, and they have organized the wonderful activity from this year, particularly to organize Nobel lecture series, and this is the initial point of organizing such type of activities. And this is the first college I can claim in Maharashtra who have organized the lecture series on the title Nobel Lecture Series 2022, and I am delivering the opening lecture, and for that one I am very much thankful to the authority and colleges also, faculty also, and my dear students of MSc second year as well as a first year. I appreciate the contribution made by our 3 students. Just their part of their work, just I have presented over here. Dr. Mubarak Sheikh, who is a faculty at Red Shikshan Samsthas, one of the colleges at Ahmednagar, that is Radhabai Kale Mahila Mahavidyalaya, who is my first student and contributed a lot in a click chemistry. Fortunately, he is working in your institution. The amide-based triazoles based on phenols as well as coumarin, made by Satish Akolkar. Presently, he is working in Syngen industry at Bangalore, having a good position and good salary. Prior to that, he has worked on Syngenta Biosciences at Goa. Just 15 days before, he has shifted to Syngen Bangalore. And the dimeric work, a part of dimeric work, just I have shared with you by carried out Tejasri Deshmukh. And I have not presented the work how carried by Danne on click chemistry. I have not shared, as well as Smita Khare, as well as Madhya Siddiqui. Their contribution is a lot in terms of click chemistry, use of click chemistry. Even though this Mininath Bhalmode, Karan Wagmare, Amol Kute, Krishna Lati, all these 4 students are presently working on design and development of new molecules by using click chemistry approach. And Dnyaneshwar Subedar, he is a group leader after having postdoc for 3 years. He has not worked on chemistry, but he has designed, developed a beautiful molecules and published more than 15 research articles in quality impact factor journals. Without help of some collaborators from various organizations, from various institutions, like an NCL, then Vishwakarma University, then Central University of Gujarat, then BITS Pilani Hyderabad campus, then YBP College of Pharmacy from Aurangabad, and many more collaborators. Without their help, their contribution, we could not able to carry out such type of beautiful work. And we have also not imagined that in future, Professor Sharpless, Professor Bertozzi, as well as Meldon will receive a Nobel Prize, as we are the followers of Click Chemistry. Without help from different funding agencies, CSIR, UGC, DST, and Dr. Babasaheb Ambedkar Marathwada University, I'm very much thankful to all the organizations, and as well as your patient listening and giving me a chance in front of you. Thank you, one and all. If you have any suggestions, questions, queries, you can raise. No problem. You can ask in English or in Marathi or in Hindi also. I'm ready to give answer. माईक द्या त्यांच्याकडे, म्हणजे मला आवाज व्यवस्थित ऐकू येईल.
Hello.
Yes.
Sir, can you please unshare your screen presentation?
Yeah. Just a minute. Yeah. Tell me.
No, sir. Just stop your sharing screen.
Okay. I will stop. Yeah. Because somebody can ask the question on my presentation. That's why I have kept.
Yes.
Okay.
If anybody having question on that topic,
other than this one also, you have to express either in English, Marathi, or Hindi.
सर मला प्रश्न नाही, पण जर मला वेळ असता आमच्याकडे मी कॉपर ॲसिटेट्स वापरले. ते कॉपर अल्काइड्स,
कॉपर ॲसिटेट्स,
कॉपर अल्काइड्स वापरले. त्याच्याऐवजी तुम्हाला दुसरे कोणते वापरता भेटला अल्काइड्स?
येस सर, शिंदे सर त्यांचं म्हणणं कॉपर ॲसिटेट का वापरलेलं आहे.
हो बरोबर, फक्त कॉपर ॲसिटेट वापरलेले, बाकीचे कॅटलिस्ट आपण वापरू शकत नाही त्यामध्ये.
I will give answer of that question. See, use of copper acetate, copper sulfate, copper oxide nanoparticles, copper base oxides, acetate as well as sulfate is used to activate the terminal alkyne.
Yeah.
One thing. Second thing, if we use other than copper, rhodium acetate is also used, but it never gives regio selectively. 1,2,3 triazose. It gives a 1,5 disubstituted. 1,5 disubstituted. Other catalysts are also used, but very few. Only rhodium, which is too much costly.
Yes.
Even though people have used copper oxide nanoparticles for synthesis of 1,2,3 triazose, many more papers on copper oxide nanoparticles.
Yes. Thank you, sir.
Yes. Now I can stop my sharing.
Yes, sir.
Thank you, sir.
Thank you, sir. Give a big hand for Dr. B.V. Shinde, sir. We have to make a library of triazole molecule, a big library. I appreciate, sir, and thank you for delivering a great or nice lecture in the Click Chemistry on Novel Lecture Series 2020-22 in our college on the occasion of MSc First Welcome Ceremony, which is organized under the guidance of Dr. K.G. Kanade Sahib. The Novel Lecture Series, which is organized because in the chemistry, 3 persons which will be contributed to in the Nobel Prize. That one is the American chemist K.B. Sharpless, American chemist Coral R. Bertozzi, and then Danish chemist Morton P. Mundell, for their great contribution in the click chemistry application to the medical field. we have organized this Nobel lecture series. Before that, one of the scientists, chemist Venkat Ramakrishnan, got Nobel Prize in chemistry for their contribution in genetic chemistry. On behalf of our college, it's our honor to present a certificate to Dr. B.B. Singte sir for his best work in click chemistry. I would like to read this certificate. Please, sir, display this certificate. Yes, sir. Yes. Give a big hand for sir. To the sir. B.B. Singte sir. This certificate we have present him for his excellence contribution in the field of click chemistry. Yes. After this, I will stop, sir.
Okay. Thank you, sir. Kanade sir, धन्यवाद.
Thank you, बाबू.
Okay. Okay. I am leaving the meeting. Shall I leave the meeting, Shinde sir?
Yes, sir. Sure, sir. If you want to leave the meeting, you can,
Yeah.
sir.
Okay.
सरकार समारंभाबद्दल झाला, परंतु कुणाच्या मनात काय दडले हे पाहण्यासाठी आपण विद्यार्थी मनोगत ऐकणार आहोत. यानंतर विद्यार्थी प्रतिनिधी म्हणून आपले मनोगत व्यक्त करेल तेजस्वी.
नमस्कार. ज्ञान ज्याचा मान आणि प्रतिमा ज्याची सोबती उत्तुंग कर्तृत्व पुढे सारे झुकून सलाम करती. येथे उपस्थित असलेले आपले सर्व गुरुजनांना नमन करून कार्य व कर्मवीरांच्या प्रतिमेला अभिवादन करून मी माझे मनोगत सुरू करतो. वास्तविक पाहता येथे आल्यापासून नेहमी काही ना काही नाविन्यपूर्ण शिकण्यास मिळत आहे. कॉलेजच्या पहिल्या दिवसापासून येथे सर्वच नवीन. कॉलेज, शिक्षक, मित्र, अगदी सर्वच. यांच्या नावागावापासून त्यांच्या बोलीभाषा ही वेगळ्याच. तेव्हा नवल करायचे, पण म्हणतात ना, वेळेनुसार प्रत्येक गोष्ट बदलते आणि माणूसही ती गोष्ट स्वीकारतो. आमचेही तसेच झाले. सुरुवातीला झालेली ओळख फक्त नावापुरतीच न राहता जीवाभावाची मैत्री पर्यंत पोहोचली. सुरुवातीला कंटाळवाने वाटणाऱ्या कॉलेजमध्ये आता मन रमू लागले आहे. आता कॉलेज हक्काचे व आवडीचे ठिकाण झाले आहे. कॉलेज सोबत वेगळेच नाते तयार झाले आहे. कॉलेजचे वातावरण हे चांगले आहे. तितकेच तेथील शिक्षक व कर्मचारी वृंद प्रत्येक अडचणीच्या वेळी धावून येणारे. अगदी प्रॅक्टिकलचे डाऊट्स सोडवण्यापासून पर्सनल प्रॉब्लेम सोडवणारे भावासारखे सांभाळणारे मित्र, आई वडिलांसारखे प्रत्येक प्रॉब्लेम सोडवणारे शिक्षक आता सगळेच आपले वाटू लागले आहे. विद्यार्थ्यांची शैक्षणिक गुणवत्ता वाढवण्याच्या दृष्टीने आणि देशाचा सुजाण व सुसंस्कृत नागरिक घडवण्यासाठी शिक्षक सतत प्रयत्नशील असतात. त्या अनुषंगाने महाविद्यालयामध्ये विविध मार्गदर्शनपर कार्यक्रमांचे आयोजन केले जाते. आयुष्य जगता प्रेझेंट आणि फ्युचर सिक्युअर करताना शिकणाऱ्या शिक्षकांच्या मानावे तेवढे आभार कमीच आहेत. शेवटी आजच्या MSc प्रथम वर्षाच्या विद्यार्थ्यांसाठी आयोजित करण्यात आलेल्या स्वागत समारंभासाठी मी एवढेच म्हणेल, अतिथींच्या आगमनाने हर्षित झाला सारा मेळा. धन्य होऊनी करीतो हा स्वागताचा सोहळा. धन्यवाद.
शिक्षण संस्थेचे माजी काउन्सिलिंग मेंबर प्रमोद बोत्रे सर, आपले या ठिकाणी सहर्ष स्वागत. सन्मान या ठिकाणी आपले कॉलेजचे प्राचार्य डॉक्टर कृषी कानडे सरांना विनंती करतो, आपण या ठिकाणी सरांचं सन्मान करायचं.
ज्यांच्या ज्ञानाच्या प्रकाशाने उजळत दिशा त्यांच्या अनुभवाच्या बोलाने जगत पाहून प्रत्येकाच्या मनात एक वेगळी भाषा
ठीक आहे. एक नाही, मी जरा एक थोडस वेगळ्याच याच्यात आहे की आपण थोडस पटकन फंक्शन तुमच्या याच्याप्रमाणे गेलो तर अजून लांबेल, अजून तुम्हाला चांगला चान्स कुठं मिळेल, म्हणून जरा थोडस शॉर्ट करतोय मी की मुळातच आज केमिस्ट्री डिपार्टमेंटच्या तर्फे जे नोबल लेक्चर सिरीज मध्ये आज जे पहिलं व्याख्यान झालेलं आहे, या वर्षीचं रिसेंट अवॉर्ड जे आहे क्लिक केमिस्ट्री 5 ऑक्टोबरला नोबल अवॉर्ड 2022 ला जे मिळालं, त्यामधले तिन्ही अमेरिकन सायंटिस्ट त्याच्यामधल्या संदर्भातला आपण डिटेल ऐकलेला आहे. आणि या संदर्भातलं जे व्याख्यान दिलं ते आपले रयत शिक्षण संस्थेवर नेहमीच प्रेम करणारे डॉक्टर बापू सिंगटे, असोसिएट प्रोफेसर बाबासाहेब आंबेडकर मराठवाडा युनिव्हर्सिटी, त्यांनी फार सुंदर लेक्चर दिलं. आणि याच सिरीज मध्ये आजचा दुसरा जो सुवर्ण योग आहे ते आपल्या कॉलेजचे माजी विद्यार्थी आहेत, या ठिकाणचे रयत शिक्षण संस्थेचे कॉमर्स मधले फॅकल्टी म्हणून त्यांनी काम केलं, मॅनेजिंग कौन्सिल सदस्य म्हणून काम केलं रयत शिक्षण संस्थेमध्ये. आमचे मित्र आहेत, इथल्या अवसरीचे आहेत, त्यांचे सरांचं लाईफ का सक्सेसफुल आहे की रयत शिक्षण संस्थेमध्ये काम केल्यानंतर माणसाचं आयुष्य जे आहे ते बदलून जातं. तुम्ही जर डिवोटेड काम केलं तर ते बदलून जातं. त्यातलं सरांचं लाईफ जर पाहिलं तर सरांचा मुलगा रोहन बोत्रे हा IPS म्हणून UP मध्ये फार चांगल्या पद्धतीने काम करतो. हा तो जो आहे तो BS US मध्ये झाला आणि आता मुलगी सुद्धा त्यांची MS झालेली आहे, ती सुद्धा एक चांगलं काम करते. मॅडमने सुद्धा आपल्या रयत शिक्षण संस्थेमध्ये काम केलं. म्हणजे डिवोटेड जर काम केलं तर तुमचं पुढचं फ्युचर सुद्धा चांगलं होतं. म्हणून सरांचं आपण एक 2 ते 5 मिनिटात आपण त्यांचं मनोगत ऐकणार आहोत, त्यानंतर कंटिन्यू करणार आहोत. पण त्याच्या पूर्वी मला एक 2 ते 3 मिनिटं या संदर्भातल्या काही गोष्टी बोलायच्या. की मला आठवतं की मी ज्या वेळेस MSc केमिस्ट्री फिजिकल केमिस्ट्री सब्जेक्ट निवडला म्हणजे काळे सर, त्यावेळेस मला ते जरा बेसिक करताना त्या टेस्ट ट्यूब वॉशिंग करणं ते करणं जसं तुम्हाला त्रास होतो तसं मला पण व्हायचं. तर ते आपले मामा लॅबोरेटरीचे मामा तुमचे कोण असतील तसे आमचे त्यावेळेचे होते, कोणतरी लॅब असिस्टंट, वॉश इट, ड्राय इट, फार खराब केली, हे केली. मला का कोण जाणे पण त्या ऑर्गॅनिक केमिस्ट्रीचं जरा राग यायचं. आणि म्हणून मला मेरिट मिळून सुद्धा मी पुणे विद्यापीठामध्ये फिजिकल केमिस्ट्रीला ऍडमिशन घेतलं. त्या ऍडमिशन घेतल्यानंतर मला असं लक्षात आलं की थोडंसं ठीक आहे, आपल्याला ह्या ज्या गोष्टी आहेत त्या थोडेसे कमी करता येतील, वॉशिंगचं जरा मटेरियल कमी होईल. आणि ते करत असताना फिजिकल केमिस्ट्रीला ऍडमिशन घेतलं. मी MPhilचं काम करताना सुद्धा असं घेतलं की कुठंच टेस्ट ट्यूब धुवायला लागलं नाही पाहिजे. म्हणजे माझा सुरुवातीचा वेगळा एम होता. म्हणून मी MPhil जे केलं ते आपल्या पर्टिक्युलर म्हणजे फूड मटेरियल्स मधल्या मिनरल अनालिसिस केलं मी बाय एन गॅमा रिएक्शन. त्याला एन गॅमा रिएक्शन म्हणतात. म्हणजे न्यूट्रॉन, स्लो न्यूट्रॉन जर ऍड केला किंवा आपण बंबार्ड केला तर त्या मटेरियल मधला असलेला आयसोटोप्स हा रेडिओ ऍक्टिव्ह होतो. आणि तो रेडिओ ऍक्टिव्ह झाल्यानंतर तात्पुरता तो रेडिओ ऍक्टिव्ह होतो आणि तो जो गॅमा एनर्जी रिलीज करतो त्या कॉम्प्युटराइज पद्धतीने मी मेजर केला. आणि म्हणून मला काहीच त्यासाठी लागलं नाही. साधे फक्त प्लास्टिकची बॅग मध्ये ते मटेरियल ठेवायचं, सोर्सला ऍक्टिव्हेट करायचं आणि वाईल ऍक्टिव्हेशन ते डिऍक्टिव्हेट होतपर्यंत रात्रभर त्या प्रकारच्या त्या गोष्टी मेजर करायच्या. थोडंसं मी खुश होतो. पण नंतर माझ्या लक्षात आलं अरे हे जे आहे ते थोडंसं जरी असेल टेक्नॉलॉजी ओरिएंटेड जरी काम असेल तर खरं काम जे आहे ते सिंथेसिस मध्ये आहे. आणि म्हणून मी माझा पर्टिक्युलर पीएचडीचा थिसिस जो आहे तो मी नॅनो मटेरियल सिंथेसिसवर घेतला. आणि नॅनो मटेरियल सिंथेसिसवर घेतलं तिथं म्हणतं बऱ्याचदा मला मग ते काय अगदी बेसिन काय सगळं ते वापरायला लागलं. त्या काय म्हणजे तुम्ही म्हणाल जे मला करायचं नव्हतं पण मी ठरवलं अरे हे चुकीचं आहे आपलं काहीतरी, आपल्या मनातलं जे काही ठरलेलं आहे ते चुकीचं आहे. कारण तुम्ही जे पास्ट थर्डची जी मुलं आहेत तुमच्या पुढे काहीतरी वेगळा आदर्श यावा या संदर्भातल्या काही गोष्टी ज्या आहेत त्या मी बोलतोय ते फार चुकीचं आहे असं वाटलं मला. जाऊ दे, कष्ट पडले तर काही हरकत नाही, पण काहीतरी करू शकतो आपण. आणि म्हणून मग मटेरियल सिंथेसिसला मी बऱ्याचदा बेसिनचा वापर केला. म्हणजे त्याच्याविषयी मला अजिबात वाईट वाटत नाही. रात्रंदिवस आम्ही काम केलं, 24 आवर काम केलं. आणि ते काम करत असताना मग मला लक्षात आलं की याच्यातूनच चांगले पेपर होतात, याच्यातून चांगल्या काही अप्लाइड गोष्टी होतात. तर नॅनो मटेरियल सिंथेसिस मध्ये मी काम केल्यानंतर बऱ्यापैकी मला थोडीशी माझी स्वतःची ओळख झाली. म्हणजे आता मी मध्ये जास्त न बोलता फक्त त्यातल्या थोडे हायलाइट्स मी तुम्हाला सांगतो रिगार्डिंग टू पर्टिक्युलर माय रिसर्च. आणि ती ओळख झाल्यानंतर मग मला परदेशामध्ये पोस्ट डॉक फेलोशिप मिळाली. त्यावेळेस पण बोत्रे सर आमच्या बरोबर होते. आम्ही दोघंही कलिग म्हणून काम करत होतो पिंपरीला. परदेशात गेलो, परदेशात मला एक वेगळी ओळख मिळाली. तिथनं मी आलो, परत प्राचार्य झालो. प्राचार्य झाल्यानंतर माझी जी मुलं आहेत ती का कोण झाली, दोघे पण थोडीफार अट्रॅक्ट झाली त्या कामाबाबतीत. तेही ते काम करायला गेले. आणि ज्यावेळेस मोठा मुलगा माझा परदेशामध्ये PhD करत असताना मी त्याला आणि विथ फॅमिली मी भेटायला गेलो आणि एका दीपावलीच्या निमित्त त्यावेळेस बारक्याही मुलाला त्याच लॅबोरेटरीमध्ये त्याच एका गाईडकडे PhDचं काम तो ज्याने आयसर मध्ये MS केलं होतं तिथं काम करत होतो. म्हणजे आपण पहा की काही गोष्टी जर क्लिक केल्या तर माझं PhDचं काम करताना जसं मगाशी बापू शिंगटेंनी सांगितलं की ही इज द फॉलोअर ऑफ क्लिक केमिस्ट्री, तसं मी त्या काळातलं पहिल्यांदा मी फॉलोअर म्हणून काय काम केलं असेल की 1972 ला फुजिशिमा अँड होंडा या ज्या माणसांनी TiO2 फोटो कॅटलिस्ट म्हणून जो वापरला, इट इज फॉर फोटो इलेक्ट्रोकेमिकल सेल, त्याच्यापासून इलेक्ट्रिकल सेलचा आपण उपयोग करू शकतो, हे त्यावेळेस मी माझ्या PhDच्या कामाच्या वेळी वाचलं आणि मी ते करायला घेतलं. आणि म्हणून माझं पुढचं जे वर्क तुम्ही जर बघितलं गुगलमध्ये तर त्याच पद्धतीचं आहे, सेमी कंडक्टिंग मटेरियल फॉर पर्टिक्युलर फोटो इलेक्ट्रिक केमिकल सेल्स. आणि ते जर तुम्ही पाहिलं तर आजचं जे इश्यू जे आहे, म्हणजे आज तुम्ही जर बघितलं असेल तर फ्युएलला आपण रिप्लेस करू शकतो हायड्रोजन एनर्जी, फ्युएलला आपण रिप्लेस करू शकतो इलेक्ट्रिकल बॅटरी. म्हणून तुम्हाला मी सांगतो की कदाचित पुढच्या काही वर्षामध्ये त्या फुजिशिमा अँड होंडाला कदाचित नोबेल प्राइज मिळेल. मी सुद्धा तो फॉलोअर होतो. मग ते करत असताना मी काम केलं. माझ्या लक्षात आलं की अरे हे काही थिंकिंग वेगवेगळ्या टाकायचे असतं, त्यासाठी काही फार लॉजिक लागत नाही. मी बोत्रे सरांना आम्ही साधे शेतकऱ्याची मुलं आहोत, तुमच्या सारखेच आम्ही आहोत. आणि मी ज्यावेळेस त्या म्हणजे वर्ल्ड रँकिंग 89 त्या विद्यापीठाचं आहे SKQ जिथं माझी मुलं शिकत होती, म्हणजे शिकत आहेत, म्हणजे तिथल्या त्या सरांच्या पुढे मी माझं लेक्चर दिलं, जसं आता बापूंनी दिलं तसं मी दिलं. आणि लेक्चर देताना म्हणजे मी सांगतो की प्राचार्य म्हणून असताना मी लेक्चर दिलं. नंतर सर म्हणाले की तुमचं जे पर ऑक्साईड जे आहे इट इज व्हेरी गुड अँड इट इज नाउ इट इज तर काहीतरी बूम होईल. म्हणजे तुम्ही के शार्पलेस जो बापू शिंगटेंनी जे अमेरिकन केमिस्ट आहे त्याचा जो पहिला पेपर तुम्ही बघितला असेल अँगो आणि केमी म्हणून, तुमच्यापैकी किती जणांचे काय तुम्ही बरेच जण जे आहेत आज जरा थोडेसे वेगळ्या मूडमध्ये आहेत, पण त्याचा जो पेपर जर तुम्ही बघितला असेल के शार्पलेसचा अँगो आणि केमी म्हणून, त्या अँगो आणि केमी मध्ये पेपर होणे किंवा त्याच्यापेक्षा हाय इम्पॅक्ट फॅक्टरच्या जर्नलमध्ये पेपर जर झाला तर समजायचं आपण कुठेतरी राईट ट्रॅकवर आहोत. आणि म्हणून मी माझ्या पोस्टडॉक कामामध्ये मी अँगो आणि केमीला जस्ट टच केलं होतं. इव्हन माझं बॅड लक, माझा पेपर पण ऍक्सेप्ट झाला होता पण थोडक्यात तो गेला. बट लेटर ऑन इट इज पब्लिश इन अनदर जर्नल, त्याचा सुद्धा चांगला इम्पॅक्ट फॅक्टर होता. मग हे करत असताना ज्यावेळेस माझ्या मनातली ती जी आयडिया होती ती थोडीशी राहिली. आणि मी प्राचार्य म्हणून जरी असलो तरी मी मुलाला आणि त्या सरांना सांगितले की सर आपण असं करूया, माझा मुलगा जो काम करतोय ना तो वेगळ्या पद्धतीचं काम करतोय, तर त्याला थोडंसं वेगळं हेट्रोस्ट्रक्चरची आपण काहीतरी आयडिया देऊया. तर त्यांनी ती आयडिया घेतली आणि मला आनंद वाटला की नंतर माझ्या मुलांनी तोच पेपर जे आहे ते SS नॅनोला पब्लिश केला. आणि म्हणजे तुमच्या मनात जर काही क्लिक असेल, तुम्ही आता MSc ला आहात, तुमचं जे एज आहे, तुमचं जे तरुणपणाचं जे लक्ष आहे, त्यात जर तुम्ही काही स्वतःविषयी डोक्यात काहीतरी क्लिक झालं, क्लिक झालं म्हणजे शेजारी कोण छान छान बसले कपडे घालून, ते त्याला क्लिक नाही म्हणत. सब्जेक्ट क्लिक झालाय. मला ह्या पुढे 2 वर्षासाठी, ह्या 2 वर्षामध्ये माझं आयुष्य मला क्लिक करायचंय. आणि त्या आयुष्यातून मला माझ्या पुढच्या एका जमेची बाजू, माझ्या आई वडिलांचं भलं करायचंय, मला काही गोष्टी क्लिक करायच्या आहेत. त्यासाठी खरं तर हे लेक्चर ठेवलेलं आहे. आजचं जे लेक्चर आहे ना ते तुम्हाला क्लिक समजूया, काय हरकत नाही, क्लिक केमिस्ट्री. पण तुम्हाला कुठं क्लिक होते का? तुम्हाला काही होते का? तुमचं कुठंतरी जागा होते का ऍजाइड, अल्कॉइड? आणि त्याच्यातून तुम्हाला काही तुमचं फ्युचर दिसतंय का? त्याच्यातून काही तुम्हाला डिझाईन करता येते का? आणि म्हणून हे ठेवलं होतं. तसं पाहिलं तर बापू सिंगटेंची माझी ओळख पण नव्हती. मी ज्यावेळेस श्रीगोंदा कॉलेजला प्राचार्य म्हणून आलो आणि श्रीगोंदा कॉलेजमधले शिंदे सर माहिती, शिंदे सरांना आम्ही त्यांना एका सेमिनारच्या निमित्ताने बोलवलं. आणि त्यावेळी लक्षात आलं की हा साधा शेतकऱ्याचा मुलगा आहे, पण हिचं सुंदर काम आहे. तिथून पुढे तो माझ्या बरोबर असोसिएट राहिला नेहमीच. मी त्याला वायसी कॉलेज सातारला इतक्या वेळेस लॉन्च केलं, चांगल्या पद्धतीने लॉन्च केलं. त्यांचं जर काम पाहिलं तुम्ही तर फार चांगलं काम आहे. इव्हन मागच्या वर्षी सुद्धा त्याला आपल्या कॉलेजला आपण बोलवलं होतं. जी सेकंडरीची मुले त्यांना आठवत असेल, म्हणजे लॉकडाऊन उठल्यानंतर त्यांना आम्ही इथं बोलवलं. खरं तर त्या वर्षी ते एका मोठ्या आजारात होते. म्हणजे ते फार, त्यांनी आपण जे म्हणतो ना फिनिक्स पक्षाप्रमाणे त्यांनी भरारी घेतलेली आहे. बापूंना मध्ये आम्ही रेग्युलरली माझे फोन असायचे, शिंदे सरांना त्या सगळ्या गोष्टी माहिती, आम्ही त्यांना धीर देत असायचं. त्या मोठ्या आजारातून ते पुढे आलेले आहे. आणि आजारातून पुढे यायला बापू जे व्यक्ती आहे ती तुमच्या समोर आज जी मुद्दाम मी वेलकम फंक्शनला का आणली, की 500 मुलं आम्ही त्यांना सातारला द्यायचो. 500 मुलांमध्ये मध्ये जाऊन ते नेम रिएक्शन शिकवायचे. त्यांना एकदा आतमध्ये सोडलं की 2-2.5 तास ते शिकवत बसायचे. आजही तुम्हाला लक्षात आलं असेल त्यांचा स्टॅमिना. एका मोठ्या आजारातून उठून सुद्धा त्यांनी आपल्याला, माझ्या हा जो हॉल आहे, म्हणजे आज मला सगळी कामं असून सुद्धा मी ऑफिसची कामं सगळ्या सह्या इथे घेतल्या. कारण का तू म्हणणार काही सरांना काही वर जाऊन सह्या करता येत नव्हत्या का? पण मी हा जो पर्टिक्युलर, त्याला आपण ह्या हॉलला एक वेगळ्या प्रकारचे हे दिलेले, याला काय काय म्हणतो आपण याला, हा व्हर्च्युअल क्लासरूम. व्हर्च्युअल क्लासरूमचे खरा जर कोणी उपयोग केला असेल आज, तर तो बापूंनी केला. तुम्ही बघितलं असेल त्यांनी त्यांचं लेक्चर देताना, पीपीटी देताना कुठेही तुम्हाला मला हलू दिलेलं नाही. त्यांनी त्याची बोलण्याची पद्धत, त्यांनी तिथं मार्किंग करण्याची पद्धत, पीपीटी करण्याची पद्धत इतकी परफेक्ट दिली. आणि मग मला वाटलं की अरे हा हॉल मधला आज जर काही उपयोग चांगला कोणी करणार असेल तर तो बापू करेल. आणि म्हणून मी माझं सगळं ऑफिसचं काम इथं मी केलं. आज एवढ्या मोठ्या आजारातून उठून ती व्यक्ती जर हे काम करते, तर मला असं वाटतं तुमचं जे वय आहे ते फार तरुण वय आहे. ह्याच वयामध्ये शिवाजी महाराजांनी स्वराज्य घडवलंय. आणि मला असं वाटतं की जे नोबल लॉरिएंट मध्ये बापूचं जे कॉन्ट्रीब्युशन आज पाहिलं आपण, थोडंसं ते फॉलोअर म्हणून कॉन्ट्रीब्युशन असेल, पण कदाचित तुमच्यापैकी एखाद्याला काही क्लिक झालं तर तुमच्यातला एक नोबल लॉरिएंट आम्हाला दिसावा. आणि म्हणून खरं तर हे लेक्चर ठेवलेलं आहे. म्हणजे तुम्ही छान छान दिसून कुठेतरी फोटोमध्ये रोजची क्लिक करून पाठवायचं, सर बघा मी आज किती सुंदर साडी घातली, सर बघा आज मी आज ड्रेस कोड घेतले, माझ्या त्या एका मुलीबरोबर मी लग्न केलं, मला आता काय जे पुढचं माझा संसार झाला. त्याच्यासाठी आम्ही शिकवत नाही. आम्हाला असं वाटतं की तुमच्यापैकी काही नाही तरी सोसायटीसाठी काहीतरी तुम्ही रिसर्च केलाय, सोसायटीसाठी काहीतरी संशोधन केलंय, सोसायटीसाठी काहीतरी तुम्ही कॉन्ट्रीब्युशन दिलंय. त्यावेळेस शिक्षक म्हणून आम्हाला समाधान मानतो. आमच्यापेक्षा आमचा विद्यार्थी मोठा व्हावा हा खरं तर होतो. आणि म्हणूनच खरं तर या ठिकाणी बोत्रे सर आले. बोत्रे सर म्हणले मी अगोदर बोलतो. म्हटलं पण सर तसं नाही, तुमचं मला माझ्यानंतर थोडंसं 1-2-3 मिनिटं आम्हाला मार्गदर्शन पण भाषण ऐकायचं की या संदर्भातलं ही आमची जी मुलं आहेत, केमिस्ट्रीची जी मुलं आहेत, दिस इज ओनली फॉर केमिस्ट्री सर, बोत्रे सर. आणि फार रिस्ट्रिक्टेड केलं की केमिस्ट्रीचीच मुलं आहेत. खरं तर यांना लोक नाव ठेवतात म्हणजे मी प्राचार्य म्हणून सांगतो तुम्हाला, म्हणतात हे काय सगळे याच्यातले आहेत लॉकडाऊन मधले, यांना काहीच येत नाही. पण मी तुम्हाला तर दाखवून द्यायचे की आम्ही लॉकडाऊन मधले जर असले तरी साध्यातले नाही. हा MSc जे आहे आमचं ते लॉकडाऊन मध्ये होणार नाही, ते ऑफलाईन मध्ये होणार आहे. आणि लोकांना आम्ही दाखवून देणार आहे, लोकांची तोंड बंद करणार आहोत की आम्ही लॉकडाऊन मधले नाव जरी असलो तरी म्हणजे ऑफलाईनच्या लोकांपेक्षाही आम्हाला चांगलं नॉलेज आहे आणि भविष्यामध्ये आम्ही चांगलंच केमिस्ट्रीच्या बाबतीत नवीन माझ्या स्वतःच्या लाईफसाठी मी माझ्या पोस्ट ग्रॅज्युएशनचा मी इतका चांगला उपयोग करणार आहे की रयत शिक्षण संस्थेचा आणि अण्णासाहेब आवटे महाविद्यालयाचं नाव मोठं करणार आहे. एवढीच अपेक्षा मी आपल्याकडनं बाळगतो आणि सर्व MSc पार्ट फर्स्टच्या विद्यार्थ्यांचं पुन्हा एकदा स्वागत करतो. पार्ट सेकंडच्या मुलांनी हा खरं तर वेलकम फंक्शन आयोजित केलं. डिपार्टमेंटचे सगळे HOD प्राध्यापक यांनी आयोजित केलं. या सगळ्यांचं अभिनंदन करून थांबतो आणि यानंतर थोडस आपण 2 मिनिटं बोत्रे सरांचं आपण मार्गदर्शन ऐकूया. त्यानंतर तुमच्या मुलांचं तुमचं कंटिन्युएशन राहील. तुमच्यासाठी कोणीतरी जेवण बिवण तयार केलं असं मी बघतोय जाता येतं काहीतरी. काही लोकांना तिकडच लक्ष आहे म्हणजे मला माहित नाही पण दिसतात काही जाता येतं वगैरे. तर त्याचं तुम्ही आस्वाद तुम्ही घेणारच आहात. त्याच्याबद्दल आम्हाला काहीच म्हणायचं नाही. एकमेकांमध्ये आपल्याला दिवसभर थांबायचंच आहे. पण तरी पण मला वाटतंय परत एकदा मी आपल्या सर्वांचं या निमित्ताने अभिनंदन करतो आणि थांबतोय.
थँक्यू सर. यानंतर मग बोत्रे सरांना मी विनंती करतो की आपण या ठिकाणी मार्गदर्शन करायचे.
आजच्या कार्यक्रमाला अनाहूतपणे आलेला मी तुमचा पाहुणा असा जरी असलो तरी मी या कॉलेजचा माजी विद्यार्थी आहे. अवसरी हे माझं गाव आहे आणि या कॉलेजचा मी माजी विद्यार्थी आहे. या कॉलेजला ज्या वेळेला 1980 साली MCOM चालू झालं. मी ग्रॅज्युएशन BCOMचं इथं केलं. पहिली जी MCOMची बॅच होती त्या MCOMच्या बॅचला मी पहिला आलेलो आहे. योगायोगाने रयत शिक्षण संस्थेमध्ये संधी मिळाली काम करण्याची. प्राध्यापक म्हणून काम पुण्यातल्या रयत शिक्षण संस्थेच्या कॉलेजमध्ये केलं आणि या महाविद्यालयामध्ये सुद्धा ज्या महाविद्यालयात शिकलो त्याच महाविद्यालयामध्ये 2010 ते 2013 या कालखंडामध्ये प्राध्यापक म्हणून काम करण्याची संधी मला या ठिकाणी मिळाली. आज आपण MScच्या फर्स्ट पार्टच्या मुलांचं सेकंड पार्टच्या मुलांनी वेलकमचा कार्यक्रम ठेवला आणि एक इंडक्शन प्रोग्राम आज या निमित्तानं आपण आयोजित केलेला आहे महाविद्यालयाने. या महाविद्यालयाचे प्राचार्य माझे मित्र डॉक्टर कानडे सर, या ठिकाणी व्यासपीठावर असणारे बोलबट सर, शिंदे सर, काळे सर, बाकी समोर बसलेले मिसाळ सर, सदाफळ सर, या ठिकाणी महाविद्यालय आमचे OS मित्र राजेंद्र मेचकर सर, या ठिकाणचे उपस्थित असणारे आपण सर्व या परिसरातले असलेले विद्यार्थी MScचे विद्यार्थी. सरांनी उल्लेख केला कदाचित कोरोनाच्या काळामध्ये आपल्याला काही संधी मिळाली असं मी म्हणणार नाही. आपण BSc झालात, MScला आलेला आहात आणि आज आता MSc करत आहात. मित्रांनो, फंडामेंटल सायन्सलाच खरे चांगले दिवस आहेत भविष्य काळामध्ये. माझं एक विधान आहे, फार महत्वाचं विधान आहे. एकदा मी काही कामानिमित्त राम ताकवले जे माझे कुलगुरू आहेत त्यांच्याकडे बसलो होतो आणि टेक्नॉलॉजीशी रिलेटेड असणारा साधारणपणे 2006, 7, 8, 9, 10 किंवा त्यावेळेचा कालावधी त्यावर चर्चा चालू होती. तर मला ते म्हटले, सर मी असं म्हटलं की सध्या इंजिनिअरिंग आर्किटेक्ट किंवा बाकीच्या ह्याला चांगले दिवस आहेत. ते म्हटले नाही सर, खरा कालावधी खरा चांगले जे दिवस आहे हे फक्त आणि फक्त फंडामेंटल सायन्सलाच राहणार आहे. त्यामुळे तुम्ही फंडामेंटल सायन्सचे विद्यार्थी आहात. खूप मोठा स्कोप आहे. दुर्दैवाने काय होतं की आपण जे एज्युकेशन घेतो त्या एज्युकेशनकडे बघण्याचा कदाचित आपणच आपल्याला अंडर एस्टिमेट करतो. कृपया तसं करू नका. खूप मोठ्या संधी मल्टीनॅशनल कंपन्यांमध्ये किंवा जागतिक लेवलवर फक्त आणि फक्त फंडामेंटल सायन्सलाच आहेत. पेटंट सारख्या सगळ्या बाबी या फक्त फंडामेंटल सायन्सचे रिलेटेड राहतायत आणि राहणार आहेत. त्यामुळे तुमच्या मला वाटतं की आज तुम्ही MSc केमिस्ट्रीचे मुलं आहे, पण आपल्या महाविद्यालयामध्ये अजूनही काही वेगवेगळे विषय आहेत. फिजिक्स आहे, झुलॉजी आहे, बॉटनी आहे, मला वाटतं मायक्रोबायोलॉजी आहे, बायोटेक्नॉलॉजी आहे, अनेक टाईपच्या फॅकल्टी आहेत. त्या स्ट्रीमचे पण विद्यार्थी आहेत आणि खूप चांगल्या पद्धतीचे दिवस या ठिकाणी तुमच्या ह्या फॅकल्टीला आहेत. कानडे सरांनी आफ्टर त्यांचं PG नोकरी लागल्यानंतर PhD पण त्यांचं केलं आणि कोरियामध्ये ते गेले. त्यांनी कोरियामध्ये जो काय अभ्यास केला त्या अभ्यासाचा त्यांनी अनुभव कथित केला. त्यांच्या मुलांना देखील त्यांनी त्या पद्धतीचं मार्गदर्शन केलं आणि कोरियामध्ये त्यांची दोन्ही मुलं शिकले, एक शिकले आणि दुसरा म्हणजे त्यांचं चालू आहे एकाचं दुसऱ्याचं पण शिक्षण. मित्रांनो, मी तुम्हाला एक सांगतो, आता तुम्ही एमएससी ला तुम्ही काम करत असताना तुम्ही नॅशनल इंटरनॅशनल पेपर पब्लिश करण्याचा ध्यास घ्या. योगायोगाने मग असे सरांनी एक उल्लेख केला. माझ्या चिरंजीवाचा एक छोटासा अनुभव मी सांगतो. माझा चिरंजीव रोहन बोत्रे ज्या वेळेला कॉलेजला होता त्यावेळेला थोडंसं आमच्या घरात आम्ही दोघं पती पत्नी प्राध्यापक असल्यामुळे घरात अकॅडमिक वातावरण सातत्याने असायचं आणि चर्चा व्हायची. त्याला आम्ही म्हणे आणि आमचं कुठे ना कुठे छोटं मोठं असं अकॅडमिक वर्क चालू असायचं. ते पेपर पब्लिश करण्यावर कधी चर्चा व्हायची तर त्यावेळेला त्याने आमचा कानोसा घेतला बोलण्याचा आणि म्हटला की पेपर पब्लिश करायचं म्हणजे काय. मग त्याच्यापासून सगळे काही गोष्टी सांगितल्या. त्याला म्हटलं की तू पण पेपर लिही. म्हटलं माझे पेपर कोण पाहणार, कोण हे करणार. मग त्याला त्या काही गोष्टीचा थोडासा गायडन्स केला. त्याने इंजिनिअरिंगचा तो सिव्हिलचा विद्यार्थी, मग त्याने त्याच्या स्ट्रीमशी रिलेटेड काही अभ्यास केला, काही पेपर तयार केले. नागपूरला पेपर दिला, औरंगाबादला दिला, मुंबईला दिला, वेगवेगळ्या ठिकाणी महाराष्ट्रात किंवा इकडं भोपाळला दिला, वेगवेगळ्या ठिकाणी भारतात काही ठिकाणी गेला, पेपर दिले, पेपर पब्लिश झाले, मासिकात छापून आले, हुरूप वाढला. नंतर एक इंटरनॅशनल नॉर्वेला कॉन्फरन्स होती, तिथं पेपर टाकला, तो पेपर सिलेक्ट झाला, नॉर्वेला गेला. नॉर्वेला गेल्यानंतर त्या ठिकाणी तो पेपर चांगल्या पद्धतीने प्रेझेंट केला, हुरूप वाढला. आणि एक पद्धतीचा रिसर्च ऍटिट्यूड कसा असतो ती बाब त्याच्यामध्ये इन्कल्केट झाली. नंतर अमेरिकेला गेला, MS झाला. थोडस मधल्या कालखंडामध्ये त्याला असं वाटलं की ठीक आहे, MS झाल्यानंतर आमची थोडीशी इच्छा होती त्यांनी तिथं राहूनच पुढे PhD करावी. पण नंतर त्यांनी थोडासा रिव्हर्स हे झाला. तो म्हटला की मला सिव्हिल सर्व्हिसचा अभ्यास करायचा. भारतामध्ये आला, सिव्हिल सर्व्हिसचा अभ्यास केला आणि IPS म्हणून 187 रँक म्हणून भारतामध्ये येऊन त्याला IPS ची पोस्ट मिळाली. पण मी एक सांगतो की त्याचा जो ऍटिट्यूड आहे तो ओरिजिनली रिसर्च माइंडेड. प्रत्येक गोष्ट रिसर्च ऍटिट्यूडनी करण्याची भूमिका, एक व्हिजन त्याच्या कामकाजामध्ये नोकरी करताना पण असतं. मित्रांनो, मी तुम्हाला सांगतो की तुम्ही ग्रामीण भागातले आहात. आपण ग्रामीण भागातलीच मुलं जास्त हार्ड वर्कर असतो. आमच्या सदाभाई सरांचे चिरंजीव सुद्धा अमेरिकेत आहे. बरेच आमच्या प्राध्यापकांचे अनेक मुलं अमेरिकेत आहे. अमेरिकेत माझी मुलगी पण अमेरिकेत शिकली. पण एक गोष्ट तुम्हाला सांगतो, लॅबोरेटरीमध्ये काम करणारी जी अमेरिकेतली मुलं, जी काही तिथल्या जगामधून जी मुलं येतात वेगळ्या देशांमधून, सगळ्यात हार्ड वर्कर कोण असेल तर 2 ते 3 देशातली मुलं असतात. एक म्हणजे चीनची मुलं आणि आशिया खंडामधले भारतातली मुलं प्रचंड हार्ड वर्कर असतात. आणि इकडे जपानचा म्हणजे आशिया खंडातले जपानचे, कोरियाची ही मुलं, आणि ह्यांच्यामध्ये इतक्या प्रमाणामध्ये हार्डवर्क करण्याची क्षमता असते. आणि हीच मुलं नंतर आज आपल्याला माहितीये की अमेरिकेमध्ये मोठ्या प्रमाणामध्ये अमेरिकेची इकॉनॉमीवर प्रभाव टाकू शकेल इतक्या प्रमाणात क्षमता आपल्या भारतीय मुलांची तिथं आहे. मोठमोठ्या कंपन्यांमध्ये किंवा जो रिसर्च व्यवस्थित कुठल्या वेगळ्या विद्यापीठांमध्ये जो केला जातोय त्याच्यामध्ये आपल्या भारतीय विद्यार्थ्यांचा अतिशय मोठा रोल आहे. त्यामुळं मित्रांनो, मी तुम्हाला एक निश्चित गोष्ट सांगतो, आज योगायोगाने मला सांगण्यासाठी व्यासपीठ मिळाले म्हणून तुम्ही MSc निश्चित करा. परंतु अमेरिकेमध्ये किंवा वेगळ्या देशामध्ये PhDच्या दृष्टिकोनातून जाण्याची मनीषा आत्ताच हे करा. त्या दृष्टीने जे काय GRE असेल, टोफेल असेल किंवा ज्या काही बाबी असतील त्याची पूर्तता करा सॅमल्टेनियसली या 2 वर्ष. पैशातून तुमचं काही अडणार नाही. मी हे तुम्हाला आता छातीवर हात ठेवून सांगतो. वेगळ्या पद्धतीच्या स्कॉलरशिप असतात. तुमचं रँकिंग चांगलं आले GRE टोफेलच्या संदर्भामध्ये किंवा GREच्या संदर्भामध्ये चांगल्या विद्यापीठांमध्ये स्कॉलरशिप मिळते. तुमचा तिथं खर्च मेंटेन होऊ शकतो. पैसे वाचून तुमचं शिक्षण किंवा तुमचं पुढचं काय अडून राहील असं मी तरी निश्चित म्हणणार नाही. खूप मोठ्या सुविधा, खूप चांगल्या पद्धतीच्या ऑपॉर्च्युनिटीज तिथं आहेत. एकदा तुम्ही तिकडे गेले की तुमचं व्हिजन पूर्ण ब्रॉड होऊन जाईल, प्रचंड ब्रॉड होईल. म्हणजे तुम्ही इमॅजिन करणार नाही की अरे माझे वडील शेतकरी, मला पोटाला चिमटा काढून त्यांनी मला शिकवलं आणि मी त्यांचं सगळं स्वप्न गेल्यानंतर पूर्णपणे साकार करतोय, ही परिस्थिती तुमची होईल. त्यामुळं तुम्ही आता ध्यास करा, एमएससी वर थांबू नका. सर मी निश्चित या विद्यार्थ्यांना सांगेल की एमएससी वर तुम्ही निश्चित थांबू नका, रिसर्च करा. रिसर्चच्या दृष्टिकोनातून काय काय करता येऊ शकतं, तुमचे जे काही सहकारी इथं आमचे प्राध्यापक आहेत यांच्याकडून तुम्ही मार्गदर्शन घ्या. आणि विद्यार्थी हा म्हणजे कोणतंही जरी वय झालं तरी विद्यार्थी हा विद्यार्थीच राहतो. स्वतः मी प्राध्यापक म्हणून काम करत असताना कॉमर्सशी रिलेटेड माझे पण नॅशनल इंटरनॅशनल पेपर पब्लिश झाले, पीएचडी केलं. आणि एक अभ्यासाकडे पाहण्याचा दृष्टिकोन, टीचिंगकडे पाहण्याचा दृष्टिकोन पूर्णपणे ब्रॉड झाला. आणि त्याचा निश्चितच वैयक्तिक, मी म्हणतो माझ्या विद्यार्थ्यांना त्याचा फायदा झालाच झाला, परंतु जो फायदा झाला तो माझ्या विद्यार्थ्यांना पण झाला. त्यामुळे मित्रांनो, तुम्हाला मी एक निश्चित सांगेल की स्वप्न फक्त एमएससी वर थांबवू नका, वेगवेगळं काहीतरी करण्याचं हे करा, परदेशात जाण्याचे हे करा, सर्च करा. आणि आता अलीकडे कोणत्या गोष्टी झाकून नाही राहिलेल्या, इंटरनेटवर सर्च केलं सगळ्या गोष्टी तुम्हाला मिळून जातील. परदेशात जाण्याचं स्वप्न पहा. पैशा वाचून तुमचं शिक्षण कधी अडून राहणार नाही. मोठी स्वप्न पहा. अब्दुल कलामांनी ज्या पद्धतीने सांगितलंय लो एम इज अ क्राईम, ती आपण आपल्या वैयक्तिक आयुष्यात त्या बाबी इम्प्लिमेंट केल्या पाहिजेत. स्वप्न जेवढं मोठं ठेवायचं, कदाचित आपल्या क्षमतेमध्ये आज दिसणार नाही. ज्या वेळेला मुलं माझे अभ्यास करत होता सिव्हिल सर्व्हिसचा, बरेच जण म्हटले की शक्य नाही होणार. मी म्हटलं करत राहा. त्यांनी पण ध्यास ठेवला, शक्य झालं. बऱ्याच वेळेला आपल्या आजूबाजूचे सांगतात अरे कशाला वर नादी लागतो, कशाला त्या अमेरिकेत किंवा कशाला ते पीएचडीचा नादी लागतो, असे अनेक जण म्हणणारे असतील. पण तुमचा रस्ता तुम्ही पकडा, मोठं ध्येय ठेवा. आणि ज्या वेळेला आपण एम मोठं ठेवतो त्याच्यातलं जरी 70-80% जरी एम साध्य झालं तर खूप मोठी अचिव्हमेंट असते. त्यामुळं आपण ग्रामीण भागातले आहोत म्हणून आपली प्रगती कोणी रोखू शकणार नाही, हा मी निश्चित संदेश या ठिकाणी देतो. आमच्यासारख्यांना ग्रामीण भागामध्ये काय म्हणतात ना, शिक्षण घेऊन सुद्धा जेवढी शक्य आहे तेवढी आम्ही आमच्या पद्धतीने प्रगती करण्याचा प्रयत्न केला. योगायोगाने इथं असे सहकारी प्राध्यापक तुम्हाला अनेक बाबतीत तुम्हाला मार्गदर्शन करतील. त्या मार्गदर्शनाचा फायदा घ्या. या ठिकाणी मला मी अचानक आलो, मला बोलण्याची संधी दिली आणि तुमची पण जेवणाची वाट काय म्हणतात ना वेळ झालेली आहे, मी गृहीत धरतो. तुमच्या आजच्या इंडक्शन प्रोग्रामला मी शुभेच्छा देतो. थांबतो. जय हिंद, जय महाराष्ट्र.
की गावाकडची मुलं काहीच करू शकत नाही, त्यांच्या शेतकऱ्याची मुलं काहीच करू शकत नाही. फक्त नोकरीच्या मागे न लागता स्वतःचे स्वप्न पूर्ण करा, कारण सुरुवातीने ते शून्यापासून करायचे असते असं बहुमत मार्गदर्शन केलं. त्यामुळे खरंच धन्यवाद. यानंतर गाडी सर मार्गदर्शन करतो.
आभार मानते त्यानंतर तुमचं कंटिन्यू.
त्यानंतर कार्यक्रमाचे आभार गाडी सर करते.
अच्छा, या एमएससीच्या स्वागत समारंभाच्या निमित्ताने उपस्थित माननीय प्राचार्य डॉक्टर प्रमोद बोत्रे सर या ठिकाणी उपस्थित झाले. त्यांनी आपल्याला मार्गदर्शन केलं, त्याबद्दल मी महाविद्यालयाच्या वतीने केमिस्ट्री विभागाच्या वतीने आभार व्यक्त करतो. तसेच आपण सर्व विद्यार्थी या ठिकाणी उपस्थित आहात. आपल्या विद्यार्थ्यांना त्यांनी जे मार्गदर्शन केलं त्यापूर्वीही माननीय प्राचार्य कानडे साहेब यांनीही मार्गदर्शन केलेलं आहे. मी फक्त उपप्राचार्य म्हणून 2 मिनिटात तुम्हाला या ठिकाणी माझं मनोगत व्यक्त करतो, तुम्हाला शुभेच्छा देतो. मी आता मान्यवरांनी जे बोललं ते रिपीट न करता मी फक्त आपल्याला एवढंच सांगू इच्छितो की आपण ज्या महाविद्यालयात शिक्षण घेत आहात हे महाविद्यालय रयत शिक्षण संस्थेचं महाविद्यालय आहे. रयत शिक्षण संस्था ही एक संस्काराचं व्यासपीठ आहे आणि आपल्याला या ठिकाणी शिक्षण घेत असताना सरांनी जसं सांगितलं की संशोधन हा एक अतिशय महत्वाचा मुद्दा आहे. एमएससी वर न थांबता आपण संशोधन करायचं आहे आणि आपल्या महाविद्यालयामध्ये केमिस्ट्री विभागाचं संशोधन केंद्र आहे. म्हणजे आपल्याला एमएससी नंतर पुढे पीएचडी साठी सुद्धा या ठिकाणीच महाविद्यालयात संधी आहे. आणि विशेष म्हणजे तुम्हाला शिकवणारे सर्व प्राध्यापक सर्व PhD आहेत, माझ्या अंदाजानुसार सर्व गाईड आहेत, प्राचार्यांपासून सर्व प्राध्यापक हे PhD चे गाईड आहेत. म्हणजे अनेकदा असं होतं की आपल्याला PhD करायची असते पण संशोधन केंद्र उपलब्ध नसतं, गाईड उपलब्ध नसतात. पण आपल्या महाविद्यालयामध्ये हे सर्व आहे. आणि हे सर्व नुसते गाईड नाहीत, तर सर्वांचा रिसर्च जर तुम्ही पाहिला, साहेबांचा रिसर्च पाहिला, इतर सर्व प्राध्यापकांचा रिसर्च पाहिला, तर अतिशय मोठ्या प्रमाणात रिसर्च आहे. सर्व विद्यार्थ्यांनी आपल्या या गुरुजनांचा जरी आदर्श घेतला तरी सुद्धा तुम्हाला भविष्यामध्ये एक अतिशय उज्ज्वल संधी या ठिकाणी प्राप्त होणार आहे. त्यामुळे मी जास्त न बोलता सर्व विद्यार्थ्यांना या ठिकाणी शुभेच्छा देतो, मान्यवरांचे आभार मानतो आणि थांबतो. धन्यवाद. तुमचा कार्यक्रम पुढे तसाच कंटिन्यू राहील.
आता एक अनाउन्समेंट असे आहे की